Duck is currently a little bit overrated.
You must give the action back.
Yeah. I have at least a white t-shirt below, so in the end,
It represents
just rescale down the resolution a bit to, I don't know, 480p or 270p.
Why didn't we just create it on AI so we wouldn't, or just pre-record it and explain the video? Really
Oh, there are no questions. Fine, I'm done.
Okay, hello and welcome everybody to Formula Students Austria and Alpe Adria Academy. Like usual for students and Formula student teams, we are not 100% punctual. So I guess we will wait for just a few minutes. So anybody who needs a drink, fetch yours now. I also hope that we can get a few more on-site participants because right now only one team found us here. Yeah. We have had about 120 participations for online registration, but that was basically 120 registrations from 70 teams roundabout. So I guess many people are participating with multiple accounts from one single team. So let's see also to pump those numbers up as well. If anybody can or wants to share anything on social media, please do that now. You can share the YouTube live stream, of course, and also the link to this live event. Both is completely public and online, so just feel free to share it. Yeah, my colleague standing beside me is Eugen.
Hi, I'm Eugen. I'm head of the electrics Scrutineering at FS4A. I will make the second presentation today.
And I'm Hoki. Sorry for not introducing myself. My actual name is Paul, but everybody knows me as Hoki, and I will be your main presenter today, and I will present the first topic, which will be about mechanical stuff. Just a short feedback from my organizers. We wait for another 5 minutes, is that okay? Okay for the audience as well?
Ele ima touch, mislim da ima touch. Ima touch.
Ali rekao je da sve jedno, ovaj lens.
Ali ne, stavio sam samo ima touch i autofokus.
A, ti si stavio jedno.
Samo klikneš. I onda klikneš set. I sad ću držati fokus.
Ajde, čekaj.
Okay, so we're going to start with session 1, which is about mechanical rules and scrutineering. And I would like to start actually with hydrogen. Just a short teaser, I will fly through those first slides. Hydrogen is now the new cool stuff in Formula Student. It has been launched in 2022, basically, and already in 2023 we had a Hydrogen Concept Challenge in 3 events, which has expanded to 6 events in 2024. And now for the 2025 season we're going to have, hopefully, the first actual hydrogen cars on track. And also there will be, again, a concept challenge. Why are we going to do that? We want to promote alternative technologies because we think that, generally speaking, hydrogen will be an important topic in the future, not necessarily related to mobility. So we don't think that hydrogen will be the biggest issue in cars, but we think that promoting hydrogen to students and to new engineers is a good idea for our future. We also want to give you the possibility to build quote-unquote green vehicles without having to deal with the high voltage system, because there are actually some teams and some universities which have trouble with that. So you can go zero emission vehicle without the need for high voltage batteries. And as I said, we want to encourage students to acquire knowledge in hydrogen. We're not alone with this. There are other multi-sport events which are dealing with hydrogen fuel cell and also hydrogen combustion prototypes. So we think this can generally be an exciting topic for the future of motorsports. As I said, we will again have the Hydrogen Concept Challenge. So if right now you are not yet ready to make a switch to actually hydrogen-powered vehicle, you can participate in a concept challenge. It will be basically a special award with prize money, at least for FS Austria. And it will also be a concept challenge, will also be available at other events. You can see here at the bottom, we have FS Austria, FS East, Croatia, Albania, Portugal, France, and also the second event in Germany, which is going to be Formula's Future. Yeah, so as I said, in 2024 there have already been 6 events which offer the concept challenge, and in the future it will at least be 6 events as well. What does this mean now for the rule set? We don't have 2 vehicle types anymore. We have now a total of 6 vehicle types, because if you count it together with all the possibilities of hybrids that we allow, you basically can have 2 different kinds of electric vehicle, one with battery electric and also one with hydrogen fuel cell. And as you can see here, for combustion vehicles you have a total of 4 options with traditional fuels, with traditional fuel and hybrid, and with hydrogen as a fuel and with or without hybrid. And as you can see here, those 6 classes in total will be competing in the 2 standard basically classes that we know already. So the idea is to implement hydrogen as a new option within the existing classes. I want to give a short overview of what is happening with hydrogen as a fuel. Title says it already, it's not more dangerous than petrol or batteries to that effect, it's just different. So hydrogen itself is not an explosive, because an explosive material is one which has basically the oxygen within itself. Hydrogen doesn't have that, it just burns really, really well. It is the least dense gas that is, so it is 14 times lighter than air. And what that means is, if you're working or dealing with hydrogen outside, it's very low risk, because at any time there is a leak, it just goes straight into the air and dissipates very quickly. And it also means that it's almost impossible, I say almost, to light anything on fire in the outside air, because it will be diluted very fast. If it catches on fire, the flame is almost invisible, so that of course is a risk. You may know that from ethanol fires, which has the same issue. So if you have like nitromethanol, I think, which is the dragster fuel, if that is on fire, so if a driver has it on their driver's seat, for example, and he is on fire, he will be like this, but it will look completely crazy because nobody sees the flame actually. So yeah, that is a problem, but the jet of flame will go straight up into the air, and if you have like, make sure that your system is all behind the driver, and the jet of flame just goes straight up, then the driver is not actually at risk. If you're working with hydrogen on the inside, so in closed rooms, it should be noted it's a better idea to not do that at all, especially in student environments. And we basically have made the whole hydrogen rules around the fact that it's easier to just switch off the hydrogen and make it the vehicle completely hydrogen free before you go inside and into your workshops. Also, of course, the low density of the hydrogen requires high pressures. If you have like about 12 liters of hydrogen at 350 bars, which has been set as the maximum pressure limit for Formula Student at this point, it is equivalent to about 1 liter of petrol. So you will need about 40 liters of pressure tank bottle for basically a combustion car, and it will be about the same size for a fuel cell electric vehicle. So of course that is a lot of extra volume in your car. How does hydrogen work for combustion vehicles? The basic engine concept is the same, so you can basically fuel a petrol engine also with hydrogen. You can use port fuel injection. Direct injection is not really that suitable yet for hydrogen. The biggest difference is that hydrogen burns really, really fast. So if you're using the same lambda values as with petrol, so a stoichiometric volume, then it burns 10 times faster than petrol. This would normally be called knocking in a petrol engine. So in order to deal with that, you have to dilute the hydrogen with lots and lots of air. So you need at least a lambda value of 2 or more to get it under control. In order to make it possible to have the same power, more or less, we are going to allow up to 1.6 liters or 1600 cc's of engine size. And most likely you will need forced induction coupled with water injection to get it under control, because it just burns differently. Also, of course, hydrogen and oxygen are very easy to ignite, so the ignition system doesn't really need a lot of energy anymore, but this also means it could ignite when it shouldn't really. So backfires into the intake system are really an issue and need to be addressed. For hydrogen fuel cell electric vehicles, we are currently working with a limit of 2 kilograms of hydrogen, but this is going to be up for debate. We're going to have a whole different session just dedicated to hydrogen at the very end of this event. In order to compensate for the additional weight of the fuel cell, we are going to allow up to 100 kilowatts of tractor system power instead of the 80 kilowatts it is today. And the only thing which we are stipulating is that at least 50% of the electric energy for the endurance has to come from the fuel cell. So basically a small battery, and you can drive your acceleration skid pad and also autocross event with that battery. Just for the endurance, we're actually forcing you to use the fuel cell. That is the current plan in order to get it started. And now at the end of the hybrid safety part, similar to the requirements for electrical cars, so similar to the ESO requirement, we're going to have the hybrid safety officer. My colleague is just right now publishing the Slido, Slido note for that. So we are going to offer a course to participate as to get trained as a hybrid system, hydrogen of course, sorry about that. So this is about hydrogen, of course, hydrogen safety officer. We're going to have a training at 22nd of February in Karlsruhe. It will be about 100 euros per person. And you can use the link now, which is in Slido, to show that you are interested into that, so that we can finalize the organization for it. Yeah, and now I would like to transition to the main course. So hydrogen is over for now, and I would like to get started with the rules. So, I'm one of the persons which are responsible for the FS rules. So I'm personally responsible for the combustion vehicle chapter of it. And I'm also, of course, in close contact with anything with regards to the technical specifications. So one of the rules which has been changed is the, I think it's in chapter A222. It's about the first year vehicle rule. Until now, it has been necessary to make significant changes to your chassis each and every year. So many teams, basically, you changed your layup, you changed your cube types, whatever, and you built a new chassis every year. Now, the new rule says you have to build a new chassis in most cases, but you can build the same chassis for multiple years. We want to make sure that, especially if you're using a monocoque chassis, that you still know how to actually laminate the car so that this skill stays within your team. So this is why we require you to manufacture a new chassis each year. But as I said, you don't have to change the layup each year anymore. And of course, this also means you can reuse your laminate test data for many years. In some cases, you can even reuse your old chassis. So this is when you're changing a powertrain type. So for example, from combustion car to electric car, you can reuse a chassis and have the same chassis for 2 years. And it is also an exception for the implementation of the autonomous system. We have made a small tweak in the definition of what is the primary structure. The anti-intrusion plate, AIP, is now also in the primary structure. It's basically a very small change. We just want to make clear you still have to test your anti-intrusion plate according to the very specific rules which are in now T3.16. It's just to make clear that the other rules, which is 3.4 and 3.6, are going to be applied to the anti-intrusion plate as well, which according to the old rules, it technically was not. In reality, it already has been. So this rule change shouldn't really make a difference for you. It's just formality, to be honest. Rule T211, good engineering practice. This is something I want to emphasize. It is not possible to write down anything into the rules. So, for example, this is a very short rule. You have to design and manufacture your car according to good engineering practice. Yeah, okay, nice and all, but what does that mean? It means you will not pass the technical inspection at FS Austria. For example, if your primary structure, if your chassis has a very bad manufacturing quality, if everything starts delaminating, for example, in the monocoque, we just won't let you through. If you have excessive flex or just a bad load path design in safety critical components like your suspension or your steering system, we consider this to be bad engineering practice and it won't be allowed. Yeah, so the typical example is that you have a steering system, the front wheels are being held in place, and you turn the steering wheel and you can flex it for like this much and nothing happens at the wheels. This is just a bad engineering design. Similar problems can occur with the brake pedal or just generally with anything related to safety. If you are not sure, you can just write us questions at rules@fsaustria.at. But generally speaking, if you're not sure if it's good enough, probably it's not good enough. A new rule change which has been made as a consequence of issues seen this year is the rule T264. This is one of the rules which is currently being updated with the FS rules version 1.1 update, which should be published in a few days, hopefully. So the new updated version of this rule will say you need to have a 5 millimeter minimum clearance in the radial direction between the rim and any other static part in your suspension. So typically this is your upright and your brake caliper. The reason why we are forced to make this rule is that many teams don't have enough clearance, and when the car is moving, the whole assembly will flex. And this will lead to problems like seen here. So this is actually a carbon fiber rim. You can see here on the right, it flexed excessively and touched the brake caliper until it was so thin that the rim actually broke, as you can see here on the left. But it's not limited to carbon fiber rims. We have definitely seen a lot of aluminium rims as well, which had very lot of deep scratches, and we had to confiscate those rims. They were not allowed to participate with these rims anymore. So, but of course, this is one of the things which we understand to be bad engineering practice if you have not enough clearance. And this is just one very specific example where now there is a rule for it. But there are thousands of other examples where we consider it to be a bad engineering practice, but we cannot put it all into the rule specifically. So this is why we have an overall rule to ban bad engineering practice. And I hope you understand. General new rules with regards to the chassis. Just reiterating, most of the stuff has already been covered, of course, by my colleagues from Germany as well. If you have steel with a low yield strength below 305 megapascals, you might need to increase your wall thickness of the tubes in the future because of the way it is now calculated in the SES. There is also now extended requirements with regards to the 3D SES file. There have been clarifications and stricter requirements with regards to asymmetric layups. So asymmetric layup means one skin is much thicker than the other one. And with regards to non-isotropic laminates, which means that you have laminates where there is not a same amount of like 0, 90, plus minus 45 degree fibers in the laminate. There is also further restrictions with regards to how you can calculate the stiffness in your SES. And there is a quote-unquote crackdown on the 3-point bending test rig compliance within the SES. But this has already been communicated like the last 5 years. So 5 years ago we started communicating to the teams, hey, your design is bad, you shouldn't use it like that. We might change it in the future, and now is finally the future. One of the rule changes, which is also just a formality basically, is we have removed the rules with regards to joining, mechanically joining a bracing. Just to make sure these designs are still allowed, we have just removed it from the rules to save space. Yeah, there is still a general rule, which is the 3.15.1. It says any attachment point between two chassis members needs to be strong enough to carry 30 kilonewtons in any direction. These designs generally can do that. So they are still allowed, you just have to show it according to the general rule. There has been a misunderstanding, so to speak, with regards to lap belt attachments. Thank you also to Theo Bratz for pointing that out. If you have a reclined driving position like seen on the right, in most cases it will not work if your attachment point to the chassis is like here at the forward, like it is shown in the picture. You might need an attachment point which is rearwards of this seat base to seat back junction point, in order to make sure that your harness has the correct angles according to that graphic, and make sure that your lap belt actually is at the right point of the hip bones, which is also another requirement in the rules. So yeah, this is also one of the things which is currently being cleaned up for the 1.1 version of the rules, of the FS rules. Some more miscellaneous parts. There has now been made an exception for blind inserts, which many teams use to basically attach their rear plate and fix their accumulators to the car. This is currently being finalized for the 1.1 version. We have now specifically allowed any type of snap ring or snap ring design, so I have to clarify, for brake test floaters. So in the past we said you can use it but only a design which was off the shelf, and now it is clear you can use any kind of brake test floaters with snap rings. A very small change in T.13, I just want to explain it. This rule means that you have to be able to safely lift and check your car with the 4 team members which have the dynamic vest. So if you need 4 members to check, to actually lift the car, and you need a 5th person to put a jack underneath the car, and you have your scrutineer for help, then you're out of luck, you're not rules compliant. Me personally, I don't mind, but FS Germany is very strict about that. They don't want to put, to basically help you with checking the car because they don't want to be liable for anything. So 4 persons have to be able to check out the car. And there's also been a question about this in Slido, about the fire extinguishers. Basically there has been a process now for multiple years on how to deal with battery fires from electric cars. And we have now come to the conclusion that a foam type extinguisher in many cases is a good idea. Previously we had the powder type. Powder is completely useless for battery fires. And if you use powder to extinguish any kind of, or try to extinguish any kind of burning electrical part, you have introduced a very fine and very corrosive powder into your electronics, and they will fail in short order. With regards to foam, it's actually much less critical. Of course, yes, it is partly water, but that can be washed away and dried. Yes, then one of the most one of the biggest rule changes for 2025 is the complete ban of ground effect devices. In the FS rules, there is a 500 watt limit. Why is it like this? Previously, we had a limit. It specifically said in the rules, active aerodynamic devices are not allowed. Then came along clever teams, and they put their radiators basically in their underground area and used completely oversized fans and said, yeah, it's not an active aerodynamic device, it's just a cooling fan. So we had to let it through. Then what we did next is, because we didn't want to argue with the teams anymore, we said, okay, let's see what happens if we just remove the ban on active aero. This was like the situation for 2 or 3 years now in the past. And let's see what happens. And what happened was that some teams, I'm not naming names, they built active power ground effect devices which were very strong, had large low voltage batteries which posed a problem on their own, and most notably they have been very, very loud. And so now we have been forced, basically we tried around with different kind of rules on how to limit it, but in the end it was no use, it wouldn't be feasible with the scrutineering resources we have to make some kind of compromise, so it's now effectively banned again. And the rule says there is a 500 watt limit on any kind of device which is moving air. Does this mean now you can build a 500 watt active aero device system? If you ask Germany, yes. If you ask me, no. We have put it into the FS Austria rulebook. The intent of this rule is clearly to ban active aerodynamics. Yeah? But we don't want to limit you on where and how you have your cooling fans. So you can have 500 watt cooling fans in your side pod. They may be designed in a way which might help you, but to be honest, with 500 watts you won't break any more skid pad records, I guess. And also specifically, in order to make sure that you don't turn up with 500 watts of siren, we have made a 160 decibel limit for these devices in the FS Austria rulebook. So if you really think that you are going to have competitive advantage with 500 watts of active aero, you can try, not at FS Austria, you can try anywhere else. I would suggest you deal with other parts of your design, and I guess you will find more points in your overall vehicle concept there. Also, to be very sure, you have to be able to prove that your system and your fans or whatever you're using to move air is limited to 500 watts. If you don't have an off-the-shelf component with a data sheet, but you have some kind of fancy self-made design, then this might lengthen your scrutineering, your technical inspection, up to an indefinite period. Yeah? And in the end, it might be easier to just remove it or put a off-the-shelf cooling fan instead. So just be warned, fancy shit technically gets bad. Some small changes in the combustion vehicle chapter. We have now the air intake system. You have two options now basically. As before, you can attach it rigidly to your engine and make like soft rubber bushings to your chassis. Or you can do the other thing as well, which until now was banned. You can make a soft connection with a rubber hose or silicone hose to your engine and attach the air intake system rigidly to your chassis. There have been some small clarifications in regards to hybrid energy storage. So how this has to be mounted and how many holes for cooling and your harness you are allowed to put in your hybrid battery. I want to pivot now from the rules to some general tips from the mechanical side. So best practices, how to design a car. It has to be clear, in order to win a race, you just first have to finish it. Yeah? So you should really focus on anything which you should focus on small issues of a car where you can improve your performance, and you shouldn't change everything just because you can. And this might or might not be directed at the people in front of me. And you should really get your car running at least 2 months before the competition, not only because testing is very important, but also because there is a vehicle status video deadline. In order to participate at the event, you have to upload a vehicle status video which shows your car is running. And this is a very strict deadline. If you're not able to show this document, this video, you will be just dropped from the list. You have already paid your participation fee. Typically you don't get that returned. Yeah, so as soon as your car drives, doesn't matter if it has wings or not, it just needs basically the most critical driver safety systems, so like the impacted actuator, you can find the list. And as soon as it drives, just make the video. It doesn't matter if the car is pretty or not, it just needs to drive. And as soon as you're able to do it, test the car, and test the car again. This is what brings you most of the points in dynamics. With regards to your design process, I would really encourage you to use the SES template as soon as possible in your design process. Last year's template will work fine for now, because generally speaking it won't change from year to year that much. Also, I want to make it clear here again, the FS Germany rules question tool, it is not intended for general design questions, so it's not intended, hey, I have this design, is it good or not? This tool is meant for this specific rule, I don't understand it, what does it mean, A or B? And also, off the record, so to speak, I know that many of your questions are not being answered in short order currently. So if you want another option to ask a question, you can also contact us. Either directly if you have very specific design-related questions, you can find our contacts on the FS Austria website, or if you need an actual official rule inquiry, you can contact rules@fsaustria.at. Also some tips to make your life easier. If you use steel in your chassis, use normal steel, which is not according to the alloyed steel requirements, and make sure that it has a yield strength above 305 megapascals, because otherwise you just have to deal with additional requirements and it's easier not to. If you're welding aluminium, like in your front tube, you will also have additional requirements. It's easier not to. And also, again, if you're using laminates which are asymmetric or non-isotropic, you also have to deal with additional requirements. It's easier to have symmetrical and quasi-isotropic laminates. It's easier to do. Some tips with regards to your suspension system, so your brakes and your wheels. Please keep it conservative. I'm circling back now to your to the good engineering practice rule. A flying wheel or a disintegrating brake disc is not a good recipe for winning a race. It might save a few grams, but that doesn't really contribute to driving through the endurance. You have to consider that the parts which are rotating at your car, they are typically under very high load cycle requirements. So every time the car is doing one rotation at the wheel, this is one load cycle. So this can add up quickly and it can lead to fatigue strength, which is typically not really an issue for race cars, which is doing like 100 kilometers. Also, again, to make sure your brake pedal and also the part of the brake pedal which is used to apply the force from the shoe, this has to be metal. So the direct surface has to be metal, but left and right of it just as a guide for your heels or your shoe. This can also be any other material. And also, just as a regular joke, it's called the brake pedal and not the brake pedal, so it shouldn't break. And we will test your brake system by applying the maximum force which a scrutineer can apply with their foot. And just be aware, we have quite a lot of stramme Wadeln in our scrutineers, so they might actually break your pedals. Yeah. Also, again, from last year, a short tip on how to deal with firewalls. Firewalls have to be sealed against the passage of fluids. Yeah? So you will need some kind of flange typically, and you will need some kind of seal material here in orange in order to make sure that you actually have a liquid-proof connection. And in order to make sure that the firewall itself is stiff enough, you typically need to use either some kind of sandwich plate material, which is here indicated with this kind of sandwich here, or you have to use geometric parts to make it more stiffer, for example, stiffening ribs. Also, I want to make sure again, there is a fire-resistant requirement for firewalls and also accumulators. You can test this yourself. You are allowed to do it. So if you have some kind of very special laminate which consists of 3 different materials, you will need to test it yourself because data sheets won't give all the information you need. So you just make test specimens according to the regulations. You take a Bunsen burner, you make a video of it, you put a clock in the background of the video to make sure, of course, that you didn't speed up the video, and then you bring the video and all the test samples to the technical inspection for reference. And that typically is not really a big deal, and you can use a big variety of designs for your firewalls or your accumulators. Also again, cooling systems. We do not want to restrict you with regards to your cooling fans. If you say you need more than 500 watts for cooling fans, we can talk about it. Give us feedback on it. We want your cars to be cool, to make it through the endurance. We know that there are typically very hot racing conditions at FS Austria and also of course in FS Accumulator. So yeah, make sure your cooling system is big enough, and if you have problems with the 500 watt fan limit, let us know. This is now my penultimate slide, and then I will go to the questions asked us. Just some more tips for mechanical inspection. We do not want to get on your nerves. We want to make sure that our competition is safe, and we want to have as many cars as possible on track. Yeah? Especially at FS Austria, we try to keep the technical inspection open for as long as necessary to get everybody through. And of course, we also have to keep it fair for everybody. So if one team has some kind of very specific design which might be an advantage, but they cannot change it, then typically speaking, we will offer them to receive penalty points, which levels the playing field, so to speak, but they can still drive. That is our way of doing it. You can prepare for the mechanical inspection by using the inspection sheet. You can find last year's example on the homepage. And also to make clear, the technical inspection is necessary for you to participate in the dynamic events. So you might not get points directly from the scrutineering, but without scrutineering, you don't get any points in dynamics. So you should treat it as important as it is. How can you prepare? As I said already, you can ask rules questions. If in doubt with your design, you should keep it conservative. Ask yourselves, does it look right? If it doesn't look right, it is a good idea to change it. You can make a dry run technical inspection with the, as I said, with the inspection sheets which are online. And if possible for you, you can participate in pre-events. And at the event itself, it is best to be prepared. So bring your documents, your data sheets, bring your test samples. And it's also a good idea to not get on the nerves of the scrutineer, because at the end, you will not have any benefit if you have spent like 3 hours arguing with the scrutineer. It will only delay your dynamic events. Okay, finally, I'm at questions now. Moderator, can you switch off my presentation now and only focus on me? So we have a lot of questions. I will sort through them shortly. One of the first questions is, the technical inspections are very different between the events. Why is that? Well, because different events have different officials which are actually organizing the event. We try, of course, to keep it consistent throughout Europe. We have more or less the same inspection sheet. We have the same rules, but every event still has the possibility to make their own version of the event, their own version of the technical inspection. That's just the part of the deal. But I can assure you, for FS Austria, we try to keep it very consistent throughout all 58 teams that we have here.
Typically speaking, there are a lot of designs which are compliant with the rules, but which are made yourself. So especially in your suspension system, you might be forced to have a special design, and you have a shaft, put a thread on it yourself, and then you put your own like hole in it for a locking wire or a cotter pin. That is completely fine. Yeah, if you have a very specific design and you're not sure, it might be best to actually make a rules question with your actual design in mind. Next question, please.
So apologies, I guess you didn't hear the last question on the stream, but we will still continue with the next question. So on SES calculation, should we take the thickness of the physical material before curing or the real thickness of the laminate?
You can use both. You just have to make sure that it's consistent through all types of documentation. So if you use 0.2 millimeters, you have to use 0.2 millimeters with regards to your bending tests, because this will then calculate your material values, and then the material values will be used and multiplied with the thicknesses that you put into your laminate documentation. So you can use both values, but it has to be consistent throughout the whole documentation. I think the next question is with regards to the Hans device.
No, there's one in here with how would the flex of a wing be tested for the ERS system?
Yeah, so how do we test the flex of wings? Generally speaking, we use our hands. So it's of course not a calibrated system, but if you shake on it, and you typically get a good idea if it is safe for use or not. If it's not clear, we can use spring scales, so the ones which have like a hook and you can pull on them and have a scale on it. And in some cases, it's also possible to just use some kind of weight, like a 6 tray of water bottles, put it on top of the wing, and see how much it flexes. Yeah, I have one question here which is still highlighted. So it's about the head and neck restraint system, Hans device. Why is it still not mandated by the rules? We actually had a big discussion in the background with regards to the rules. We had a lot of people and a lot of teams also which wanted us to make it mandatory. We decided against it because you are allowed to use it, but we didn't want to make it mandatory because there's already lots and lots of things that you have to do. And you already have to buy new racing suits because some of the old rules are not allowed anymore. Many teams have to use, they have to buy new helmets. And we didn't want to burden you with also having to buy a new head and neck restraint system. And we have also made a worldwide survey, so we have reached out also to America especially, which kind of accidents are actually relevant for us. And a high-speed, straight-on impact into a fixed barrier, where a head and neck restraint system, which will actually help you, is very, very uncommon for Formula Student cars. So this is why we have decided against making it mandatory for us. But again, if you want to, you can use it. Yeah, and if you have the resources to do it, we even encourage you to use it, but we don't want to make it mandatory at this point.
How are you going to check the wheel rim clearance at Scrutineering?
So this is very simple, basically. You take a 5 millimeter thick cable, so a steel cable is perfect for it, and you just pass it around on the inside of the rim. You put the front wheels into any kind of steering angle. And if necessary, we can also like push the car down with a bit of weight, like put the drive into the car or lift it up to make sure that the clearance is there for all kinds of ride height as well.
If the structural material in TSIC is resistant to 600 degrees but has no certificate, could we perform tests ourselves and make a video of the self-tests applied just for the firewall?
Yes, definitely. I already said it in the presentation. You can make your own tests. You just have to properly document it.
Why switch to foam type fire extinguishers? According to our information, those are not rated for electrical fires.
We have to distinguish between a proper electrical fire, which is typically like a substation burning, or and many extinguishers say on it only suitable for electrical fires up to 1000 volts. Yeah, this is typically the case also for foam type extinguishers. As you know, we have a 600 volt limit on our cars, so you can use a foam type extinguisher to extinguish a car. And as I said already, foam is much more suitable for the broad variety of fires that we might encounter in a foamless student car with regards, in comparison to the old powder type. And the last question?
How to understand the general name of TAB washer? This is rather a broad group of security washers, some of which, depending on the FS competition, are accepted or not. Please clarify.
A tab washer is a kind of washer where you have a part of it which can be bent in order to secure your fastener against loosening. There is multitude of design on how to do that. Mostly you just have some kind of sheet metal which has some kind of tongue which then can be folded. It's up, as I said already, every competition has their own actors which have their own mind. There is no 100% fail-safe norm, specification which is available for anybody, which says this is a tab washer and this is not. So in the end, if you're not sure, please post a rules question. I see there are more questions coming in, so I will speed run through it. We have thermal. Oh, this is for my colleague then, and we have a 500 watt rule. Yes, the 500 watt rule again. It is of course the total power, means the combined total power of all your devices. You are not allowed to use 20 times 400 watt fans in your car. This is clearly against the rule. So any sum of your devices which move air, typically fans, the sum combined total must be below 500 watts. And because of very special questions like this, we are going to revise the wording of the version 1.1 rule. It will say combined total maximum power. I hope this is then finally clear. And the last question is about, I think, the attachment of the rear wing. Where is it now? Labels. Here. So the attachment point of your rear wing to the main hoop bracing is not allowed without additional support. I didn't have this in my presentation. But yes, there is basically within 50 millimeters of your junction point, you're allowed to put a rear wing attachment without having to use an additional bracing. Yes, that is correct. In this very specific case, please refer to the FSG Academy slides because they had it in the presentation. I did not. Yeah, so thank you very much. This is it for the first session. We will have a short 5-minute break, and then my colleague will take over. Thank you very much. See you again.
Okay, hello again. Now from my side, I will talk a little bit of the EV parts of the rules. So what has changed and why it had changed. And yeah. So, one of the first rules that have changed is the EV 1.2.2. It hasn't changed, there's only one clarification. So what is a high current path? And already some team members asked me, yeah, but what about gate driver current? What about ECU current and so on? No, it's quite simple. Only the RMS value is in focus of this rule. So if you have some pulsed gate drivers with a few amps, it doesn't matter, that's not the high current path. Also, it's only the tractive system current. So for your cooling fans, for your DV ECUs, for your inverter power supply, the low voltage power supply, that's still normal rules. So there are no high current rules applicable. So, and the next very big change, where is very much rumors, is the rule EV 3.1.3. That's about grounding. You have to, so especially the 100 milliohms. Yes, it's a tough rule. It's not so easy to get this 100 milliohms. But you have to keep an eye on EV3 on the rule before. There is defined what have to be grounded. So you don't have to have this grounding through the whole car. Only firewall, inverter housing, tractive system housings, and other stuff that's mentioned in the rule before is needed to have this 100 milliohms. And the next thing is the measurement point for the low voltage ground is not the grounding point from your car. You can define where's your grounding point. When you say it's exactly there, then it's difficult. But if you say your main hub is your ground, then it's quite easier, because for EMC reason, I would suggest you put all cables to one grounding point and connect everything there. And from this point, there will be the measurement. It's quite easy. It's quite easy to have it done by the measurement point, but there will be some methods to do this in Austria, that we measure it to your grounding point. It would be nice if it's accessible. If not, you might lose quite much time in scrutineering. And at least for FS4A, I can promise you there will be no team that's not driving because they can't reach this 100 milliohms. There will always be a solution. If the team is happy with the solution, is another topic. Yeah, another small change is about the RMS voltage, the 600 volt voltage. Till now, it was in the rules allowed to have it in the inverter a little bit more than 600 volts for the gate signals. Now there's also this exemption for the AMS. It is important to don't have any, to never have more than 600 volts at the accumulator connector, not at the data logger, because more than 600 volt at the data logger will be a DQ. So always be careful about your braking energy. Yeah. We also changed the clearance and creepage rule a little bit. For the creepage path, for the clearance, to have a better clearance, you can now cut your PCB, but always be careful. You have the creepage path over the chip also, and you can't cut the chip. So normally this won't work. So just do coating if you can't reach the distance. And with the coating, you get to the 4 millimeters, and it's quite easy to get the 4 millimeter chips. The next big topic, FF4 was banned from stacks. This was a little bit, not so intended as it is now. There will be a rule change in the version 1.1. It's about, we had it in 2 years ago in FS Austria, last year in Germany. There are always teams that stack their accumulator PCBs. They have one PCB, then over there's the cell tabs, and over there's the bus bar. And all second with one screw, and the PCB will bend a little bit, and then you have the force only at one point of the bus of the cell tabs, and that's simply not allowed. That's simply not okay. That's a safety issue. We didn't let the team thrive with this solution, so they spent the week by rebuilding the accumulator, and yeah, that's not funny. That's not how it should be, and so there will be the rule a little bit relaxed. So if you have really a stack with FF4 in it, it will be allowed, but there will be restrictions. So there are also some clarification with the directive system measurement points, especially soldering. So as I did it when I was in the team, and I saw it at many teams, is to solder the wires for the measurement points directly to the measurement points. They are not built for this. That's not working really good, and with flexing, it will break. The measurement points are you need them immediately because that's your last line of defense. When you don't know, is it the car working or not, the taser is broken for some reason, then you have to have something where you can measure it. And there you need the measurement points, so they're really, really important. The same for the T-cell. They are very much, they're very important. So when you have connectors, because you have the measurement points, they invert in the housing and something like this, the connector must have an interlock. So if you forget to connect it, the car will not start, mostly. And and at the measurement points, the best solution is a wire lock and a lock nut. There was a rule that spare directive system accumulators must have the same dimension and weight and type as the original accumulators. This was deleted. This means basically because that there are no spare containers allowed anymore. The simple reason is we have not seen it anymore at the team. So nobody built a second container just for fun, and so this rule was deleted. You are now only allowed to have one container at the event. But still is allowed to have multiple containers, so to have one container in the front and one in the back, or one on the right side, one on the left side, or something like this. That's still allowed. But you have all of them shown at the accumulator inspection, and they all must be built in the car at the same time. For the accumulator indicator, the last 2 years, it got modern. We saw it that the indicator light was flashing at some teams. And you saw it clearly, it was not intended that it's flashing. It's just the team built it and it started flashing because they did not proper cooling for the chip, for the LDO chip or for the buck converter. It got hot. It turned off because of over temperature. It cooled down a little bit and it turned on. And so we had a flashing of 1 hertz or ½ hertz or something like this. And we said, no, that's not okay. The LED must now light the whole time. it must be on a constant level, no shimmering, no dimming. And it's also possible with the Viper 06 that some teams use for this application, and it works fine. You just have to know how to do it. Yeah, the last few years we had the Accumulator segments for the SES and sections for that you don't have to more than 60 volts, 130 volts, or 6 megajoules. This is now combined to one thing, so you have to. Most teams had always like this. There are always some teams with special solutions, and it was always arguing. So nowadays we have segments, maximum 120 volts or 6 megajoules, and between these we have to you have to have these firewalls. Now they have to go up to the ceiling of the container, so the whole time. But 25% of the of these walls might have holes. Okay. Also, a small clarification about the AMS laptop. So, according to the rules, you must have a laptop or a device to read out your the status of your battery, of your high voltage battery. So, temperature and voltages. Most teams use a laptop, and there are always, every year, 1 or 2 teams that have a laptop but no battery. Battery is broken, battery is down, it's an old laptop, they found somewhere, they use for this. Just use the laptop of a student for this, from the ESO or something like this, with a working battery. You must be able to read out the voltages during testing, during the endurance. If there's an AMS error, you have to know what is the problem, and then you need your laptop. Or you have some other kind of device, some tablet, or you can do it by Bluetooth with your phone. That's all suitable, but it has to be mobile. There's a new vendor, IMD, the ISO 175. Quite nice part. It has a CAN interface. With the CAN interface, you can read out the voltages and the isolation resistance. Really nice if you use it. With this CAN interface, you also can change the response value. Don't change it. It won't help it because it won't help you, because we will measure the IMD response value after the event, after the endurance, after the acceleration, and so on, especially when it's raining. And after the rain test, clearly, we will change to test it with the resistance you need. So, yes, you can change it. The problem is when we find out that teams will change it for some reason that won't help them. But if you do it, we will block the CAN interface, and then you are not allowed anymore to read out your resistance. Would be nice for logging or whatever you want. So just don't do it. Yeah, diesel screen light must be available at the accumulator charger. This is basically because we want to change the process of scrutineering. We strongly recommend you to insert all the signals, all the logic for the green T-cell inside the accumulator. It's definitely allowed by the rules, and then you don't have to do very much at the charger because you just have to implement one LED. Yeah. If you want to have your logic in your car, then practically you have to do the same at your charger, the same logic, and we will test it. So We will open the stacking air detection and have a look if the error is pending or is latching. So the LED error status is latching. We will do some different voltages between the input and the shutdown circuit. So everything that's in the rules will be tested in Scrutineering next year. So keep your logic in your accumulator. Maybe have connectors to disconnect the airs, just that we can check if there is a stacking air detection working, and or if it's not working, then then it's not okay. Yeah, that was the changes in the EV rule. It was not so much. Are there any questions from here or from Slido?
Yeah, there's a lot of questions, so let's get to it. So first question is regarding the indicator. Could you clarify if using a digital voltmeter powered by an isolated flyback converter complies with rule EV5410? Since the question references that the voltmeter is purely built in hardware, so it should be valid.
It should be okay as long as this DC-DC is only hardware and is not backed up with software, has no microcontroller in it. But why should I do this? So I think it's allowed. I think it's okay. It always depends on the implementation. But I can, as I understand the question, I can't see why it's not allowed. But yeah, yes, it is allowed.
Can TSAC have cooling holes on the structural wall facing the driver, so through the firewall, if it has ducts made out of fire retardant material that is mounted on the same wall and redirects holes to the sides away from the driver?
That's always a question of definition. When your ducts are parts of the TSAC, it's allowed. So if they are always mounted, if they are glued or something like this, then they have to be from material that the TSAC can be, so fire retardant material and so on. So if you do it the right way, yes, it is allowed. If you do it the wrong way, it's not allowed. Quite simple.
Okay, next question. Is a thermal simulation of the battery pack required for the tech inspection?
No. Quite simple, no.
Okay. Does the change of the rule EV722 wants to keep the relay arms the relay disarmed if the STC is closed again, or is it okay to arm the relays again and control the charging process with software?
We mainly synchronize the rules for the car and the rules for the charger. So it's the same as in the car. If you press the shutter button and you release it, till now it was allowed that the charger will start immediately. Now you have a dedicated, you have to have a dedicated start button. So when the shutter button is closed, everything is closed, then you can press this start button and it will start up.
Does the T-cell on the charger need to comply with only EV4103, or has it to comply with all the rules of the green light in T-cell?
I think the EV4103 are the rules about the T-cell. I'm not sure now, but normally. Yeah, EV4103 are the rules for the green T-cell. So I don't know. I don't understand the question.
Oh, okay, maybe we'll sort it out later in chat.
Yeah.
Is a soldering nut, hot melt nut, okay to be used for screwing in the maintenance plugs?
I don't know what a soldering nut is. Do you know?
I think this refers to hot melt nuts, which you can use to make a metal insert into like a 3D printed part. And you put that basically on top of your soldering iron. It heats up, and then you can push it into a 3D printed material.
Yeah.
But this is not soldering in the context of it's a soldered connection, which is not allowed in the high current path. I think this is the background of the question.
Okay.
So it's not soldering, but it's also not like a proper type of mechanical connection for bolts.
I don't know if you want to fix the bolt, and there's only the strength of the bolt, and then otherwise it would be fly around. In my opinion, it would be okay, but there are much better solutions. So
Yeah, maybe this is also one of the issues where it might be best to actually mail us a rules question with a picture or screenshot of your design.
would be better, yes.
Okay, what counts as a wired connection on an accumulator temperature sensor, and where you have to be able to disconnect it in the scrutineering?
A wire connection, if you have THT sensors, then it's always a discussion. If they are very short, then they sometimes say it's okay, but normally that's already a wired connection. If you have cables, that's clearly a wired connection. When you have an SMD part and you press the whole PCB on the cell or on the bus bar, and the AMS chip is on the same PCB, so there's only wiring through the PCB, then it's not a wire connection. And where to test it, you have to simulate a broken wire. It is okay to have tip switches on the PCB. When you open the tip switch, then it's the same. So when you route, you have a connector soldered your wires in, then you route it to the tip switch, and then you route to the AMS chip. This will be completely fine for me. You can also insert a Zwischen connector, so that you connect all your temperature cables, open this connector and put some PCB between with dip switches just for scrutineering to show a broken wire. A single broken wire will lead to an AMS fault. That would be fine for me. Yeah.
So an intermediate PCB for testing.
Exactly. Intermediate PCB for testing. Exactly. That's also something you can do at the brake on the accelerator pedal. Also, there's sometimes better to have an intermediate PCB than to work inside the car.
Will there be again a 30 milliamp RCD in FS Austria 2025?
Yes.
Do you care to elaborate?
No.
What is an RCD value for us non-electricians?
That's the FE in German,
Okay.
and 30 milliamp are standard for households, and so it's a standard RCD. There are special RCD for industrial environments. We don't have an industrial environment, so we need to have the 30 milliamp RCD. Quite simple, we will have a 30 milliamp RCD.
So if your electrical equipment triggers this circuit breaker, then you will have a bad time. Sorry about that.
Yep.
We can't change it. It's just not allowed. Okay. Can the electronics compartment of your TSAC be made out of electronically insulating material, while the rest of the segments are made of metal, so are electrically conductive?
Basically, I would say yes, but make your rule questions with your pictures. What you really want to do, because but you can, everything that's electric conductive must be grounded. I think it's getting harder for you if you mix this up, but make your rule questions.
I think it might be possible or easiest if you have like actually compartments which are sealed by itself, and you'd say, okay, this is an actual electronic box, and you have like a cable running in between. But this is not possible for some parts of the accumulator, right?
Yeah, that's
Yeah.
make a good question.
Yes.
Question.
Okay, so this is about the mechanical rules for the accumulator. The fasteners of non-structural parts, like the ARR, they do not have to follow the rules with regards to the size of the bolts, which is T1012. Can hexagons? I already answered that. So there is quite a lot of rules about safety fasteners, which is the chapter T10. In this case, we allow small fasteners to be used in any kind of application, but it still has to be like a socket head cap screw or a hexagonal type bolt, because these are the only type of bolts where we say we can properly check them and these are proper fasteners. Answered. Green teaser light during charging, EV7.9. Should the teasel include the latching? We don't have the teasel logic implemented inside of the accumulator, so could you please clarify?
Yes, they should include latching. They should include everything as in for the green teasel. And as I said already, you will have a better life at scrutineering when you're including this in your accumulator.
EV 3.1.1. Can the accumulator be constructed of multiple different materials? So this is basically the same question as before.
If there can be a stack.
Yes, but it is still about, so the rule EV 3.1.1, it says you can either make your whole accumulator out of non-conductive materials. So typically speaking, this would be a laminate out of glass fibers or with aramid fibers. Of course, in that case, everything is non-conductive, and if there is like some kind of shortcut, everything is isolating, so there is no issue. As soon as you start having metal parts, so conductive parts in the accumulator, everything has to be conductive and grounded.
Yeah, but the inner side of the accumulator must be isolating. So basically, you have to have conducting and non-conducting layers in one stack, in one stack. And so the inner side must be non-conductive. And if you have some conductive metal in the outside, it's up to you, but it has to be grounded.
I suspect that the background for this question is a very specific design, and also here it would be best if you just submit the rules question with a screenshot of your design so that we better understand it. Penultimate question, for the accumulator SCS, in order to measure the height of the panels, how should you take the measurement if there are holes for ventilation? I think this refers to the panel height, which is basically with regards to the structural integrity. So if you have like a wall, do we have like a chart? Haben wir Kreide? Okay, sorry, we have nothing to draw. But for mechanical purposes, you have to use the. Thank you.
Hirte? Hirte? Kannst du die Kamera ein bisschen dran?
Get this. So, if you have your accumulator, basically, in this case, we have a section view. You have your stacks here. And here on top, you have some kind of bus bar and your wires and whatever. Then I guess you will have an opening here, shaped like this, probably, in your internal wall, which allows for the passage of your bus bars and also for your cables. And I guess, like here, for example, like this, you might have some holes for ventilation. Of course, with regards to how many holes you can have with regards to the 25% rule, this light here, this and this are holes, and this area must be below 25% of the whole area. And the whole area goes until the top of the container in this case. This is the new rule. And now with regards to the mechanical and how to implement it in your SES, you have to take basically the section which is the weakest point, which is right here, and the remaining panel height, which is this value plus this value. This is the panel height which remains with regards to your structural equivalency, and this is the panel height that you put into your accumulator SES for the structural documentation.
Okay, I think I can answer this. Yeah,
yes. So we have one question with regards to EV 3.1.3, which is regarding the 100 milliohm requirement for grounding. This appears to be impractical to achieve, particularly in areas such as screws around the TESAC housing. How strict is this rule going to be enforced at FS Austria?
As already said, no team will not drive because they can't fulfill this rule. There will be other solutions, but you can fulfill it. You can use quite thick wires. That's possible. Also, yeah, this is not impossible. If you have only very, very thin wires, then it's not possible, but you have to use thicker wires and proper grounding, then it's not a big deal. Also, to have you have to have the 10% of the accumulator fuse, so your wires must be able to carry 10% of the accumulator fuse current, and from this, when you have this thick wires, there is no problem. So
I just saw one more question which is related to electrical.
okay.
It is about the electronic. Yeah, so it is about electronic throttle. Of course, this is with regards to combustion cars. The question is, we have one sensor and it has multiple output wires. One of those wires gives like the normal signal and another wire gives the inverted sensor signal. Are we allowed to use the inverted sensor signal as the second required sensor? Answer is a clear no. It says you need to have two signal outputs which have non-parallel and non-intersecting variables. So if you have we're talking about two sensors. You have your throttle position in percentages from 0 to 100. And you have typically your voltage for the sensor. And you need one sensor which is like this, for example. And you need a second sensor which goes, for example, like this. And the reason behind it is that at no point of the throttle position do you have an intersection between the two signals. At every point you can tell, okay, this sensor should be here, this sensor should be here, the signal is okay. And when the other thing would be, like you are trying to propose, that the second signal is like here in green, then you have one point where both signal outputs are exactly the same, and the system cannot tell if actually both signals are still working or there is a shortcut between the signals and both signals are the same because of the shortcut. So no, this is not allowed. You have to use 2 actual sensors, but there are some sensors which in one case have 2 signal outputs which are non-intersecting, which allow this.
That's the automotive standard, so there are quite much of these sensors available on the market.
Yeah. Okay, as of now, I cannot see any more questions. Maybe right now I will overtake the room and see if some of our on-site participants have some kind of questions. Don't worry, you won't be in the video. We won't see your beer. But yeah, maybe I think most of you here are teams with electric cars. And I guess you have some questions. Do you care to ask them now?
I asked already online.
Okay, so you don't have any more questions? Because we have to bridge some time. Maybe the guys from Vienna. Oh, they are so shy. Again, you are not on video, you will be anonymous. Okay, then in the meantime, I can see if there are some more online questions which I can answer already, because our next block will only start at 4 o'clock sharp.
Machen wir Pause.
Yeah, let's see. I think there have been some questions with regards to accumulator documentation. Yes, this one here. Okay, my moderator told me to just make more breaks. The next session will start at 4 p.m. We will have two streams in parallel to each other. So the main stream right here will be about cost report, and the secondary stream where you can find on the left of your Slido interaction sheet, which I can. Yeah, I should be able to find it. If you found the first stream, you will be able to find the second stream as well. There has been a small change in the background, so click the link again. It is a new link now. And on the secondary stream, on the secondary live stream, there will be the business presentation event. Yeah, so next session, statics, in 20 minutes. See you there. Until then, we make a break. Thank you.
So, hello everyone. In this presentation we will talk about cost, as you see it up there, how it's made. My name is Clemen, I come from FS4A Adria.
And my name is Sebastian, head of cost for FS Austria.
So for this year, for the cost, we have some major changes. So we've already seen questions from the teams. We already seen questions from the teams at FSG Academy. We saw that a lot of teams are a bit shocked, like a lot of new stuff, a lot of things to do. But we will go through everything today. So there are major rule changes for this year for the cost. We will talk mostly about the CC boom. What is CC boom? How can you handle it? How can you approach it? We will also talk some things about what is going to be different at Alpe Adria and Austria in comparison to FSG. And in the end, we will do a Q&A session. For some rules were not exactly changed, they were just moved around in the rulebook. They're not different, but we wanted to emphasize them because a lot of teams do not have cars prepared for the judging. Mostly at the competitions where the judging is done in the pits, the teams are still assembling the car, they're still working on the car, and it is impossible to do the whole judging process, especially for the boom. So this rule and also this one is really important, and as we will see later, there will be bigger consequences this year if the teams are not prepared. But the other things that will change is changed bill of material systems. We will go through all the major changes, but let's start with this. So the division of the systems in the car changed a bit for this year. This is to make it a bit easier for the EV teams and also to keep in mind the CV teams. So the engine and drivetrain system was divided a bit. So engine and tractor system will get their own category, and the drivetrain will go into its separate category. And also for the low voltage system, it is a bit clarified which part of the low voltage system do we talk about. Regarding this, there was already one question on Slido that was asked. So if the engine and drivetrain has been split into systems, how do we decide which part goes to which system? Our answer is it's the same for what have you been doing so far. So if you have a part and you're not sure where it goes, first thing you look in the online boom tool on the FSG website. There you will have for different systems list of parts, and it will determine it for you where that part goes. If it's not there, if it's not clear, it is totally up to you. So you get to decide in which system that part or assembly goes. But try to keep it simple, try to make it make sense, because it will have to be logical, and you may be asked what is your thinking behind, why did you put that part in that system. But our advice as also a judge is show us what you know. So don't try to hide systems in the different systems. If you have the possibility, show us what you know, put everything and show it to us.
Okay, then let's move on for further changes. One of the biggest ones, which will impact maybe the teams the most, is the increased penalty for using newer cost report documents, because last year, especially in FSA, we had an issue that in the uploaded documents you have a timestamp which is before the deadline, and then you are showing us documents which are after the deadline. According to the FSG rules last year, I think you got deducted, I don't know, 5 points or something. Now, if you're using newer cost report documents, you will basically get 0. That's it. We will not judge you for the bomb. We will just go on. Done. That's it. So please take care to use exactly those documents what you uploaded, and nothing like newer ones or different ones whatsoever. If the timestamp is different, we will basically just use 0 points and that's it. And now the most crucial one for you, I think, for the work perspective is that the D bomb and the C bomb are gone and a new bomb is included, the costed carbonized bomb. So in the end, the D bomb is replaced completely, it's gone. The C bomb is not gone, but it's getting additional column, which is the CO2. But why? The reason behind is that the overall term or the long-term goal of at least the European Union, also from other major industrial nations worldwide, is to reduce the CO2 emissions. And if you want to reduce CO2 emissions, you have to know what are my emissions overall. So also this new Green Deal from the European Union is funding a lot of different projects. So you get a lot of money if you are doing green technology, or at least what is considered green. So you have a lot of different national programs, European programs, where you get money if you are becoming more green or if you are doing something differently. So the CC bomb the costed is still the same, costed bill of material, and there is now the carbonized as well. So there will be, from the structural point of view of the bomb, still the same. So you have a column for the costs itself, like it costs 6030 or 2469. And there will be a new column where you put in your CO2 equivalents. The CO2 equivalents overall are, of course, you have not only CO2, you have methane gases or other gases as well, but they can be calculated into CO2 equivalents to make it even for all the teams. And as you see, the D bomb and the C bomb are now gone, and you have the bomb, the old bomb, what we already know, with all the different systems, and the CC bomb with only one system. Could be the steering system this year, if I'm not mistaken. Yeah. What to include? If you already followed the FSG Academy, it's cradle to gate. So from the beginning to until the part reaches the endpoint, which is most probably your car. So including the raw material, where is the raw material coming from? Maybe aluminum, steel, whatsoever is coming from China, or you have a local supplier, it depends where you're from. So how much CO2 is getting produced per kilogram, per ton, whatsoever, on the raw material? Where you get those numbers from, it's up to you. So either you call different companies, or you have Google, you have scientific papers, you have company announcements, whatsoever. Then, of course, those raw material has to come from point A to point B. Most probably it will be ending up in a different point where you are currently located. So maybe in Germany or in Austria, it's somewhere and then post-processed, like cutting into the different lengths, what you need. Then it's getting transported to your workshop as well. Maybe it will be then outsourced to a different supplier for machining as well. Then you have additional transport costs, or you machine it by yourself. What you include in your machining, same thing, up to you. If you consider everything like electricity, lights, lubricants, then the overall power consumption of the machine, if it's in idle, if it's in programming, if it's in real machining, if it's just standing there and waiting for something else to happen. It depends how you include everything. And as we already saw in the C-bomb in the very early stages in 2017, 2018, in the first few years, we were a little bit, we were not expecting so much, but we were surprised. And then it got better over years. So this is a starting point, and then we will see where we end up in the next years. And assembly overhead costs as well. What kind of overhead costs do we include? It's in the end the same thing as in the current CBOM. Some teams are implementing already or having overhead costs what we were not expecting. Some teams were basically just scratching on the surface. CBOM sources, there is the ISO 14064, then the GHG protocol, and what Clement found out is that in the FS4A UK from 2009 to 2016, there was already something considering the CO2 emissions of your cost report as well. So maybe if your team already participated back then in a UK competition, you can search through your old documents. And of course, Google. Any kind of scientific papers, any articles, whatever. And the thing is, as long as you can, of course, you can find a scientific paper saying 1 kilogram of aluminum out of China produces 100 kilogram of CO2 emissions or 1 ton of CO2 emissions. Then you have to justify, okay, whom or which paper do you trust more? As long as you justify your thoughts, should be fine. We will not pinpoint you down like, okay, but we know that 1 kilogram of aluminum is exactly X kilogram of CO2 equivalents. Of course, it's depending on the country, on the company, on the transportation systems, on everything. As long as you are explaining your thoughts and back up your thoughts with some kind of numbers, should be fine. Okay. Then let's hand over back to Clement.
Yeah, so we know that it's not going to be simple for you, but this is Formula Student. We want to give you a challenge, and we want to challenge also the teams that might rely already very much on previous year's teams' work, where they just update whatever they have. So here, we are really going to start from zero, at least for the calculations of emissions. And that means that everybody will be on the same ground. So when the first edition of the FSG rules came out and it was announced, then everybody started working with that at the same time. It will be really interesting to see what you will come up with, because we know that not all the teams are going to have the same level of detail, the same approach, and also the same sources. But we will see what will happen. And of course, next year and every subsequent year, it will be much easier because you will already have a basis you are working on. Maybe you can take it as a bit of a bad luck that this generation of people working on a cost report will have to do this. We know it's a lot of work, but I think
still easier than 2015.
Yeah. But yeah, next year it will be easier. Every year it will be easier because you will just add to the basis that you will have, which is a good maybe point in your history of Formula Student, because it's a huge jump that you maybe try to get to the next level and maybe start everything from zero, the whole system in your team. Who knows? And of course, the judges that will judge you this year, they will be informed. They will know that this is a thing that the teams were tasked for the first time. They will, depending on the competition, they will adapt the judging. But the important thing is that all the teams will be judged on the same level. So we will see what you come up with. One of the advices from the judges, from us, is that you plan in advance, plan well. Some teams don't do this, but really the first thing in the season you should complete is the cost explanation file, because with that file you then create the whole CC-boom, and you take that as a basis. And that means that you can plan in advance in what detail you will go in the CBOOM and also in the emissions calculation. So you don't lose too much time working in a lot of details, like in starting with some parts, and then you find out it's already June, and then you rush it till the end of the season. Try to prepare, work in advance in how much detail you will go, and then stick to it. So you don't end up with hills and valleys, but across the whole cost report, whatever the thing judges ask you to show, it's done to the same detail. Because it does happen that we ask, for example, explain us how do you calculate this part, and then the team says, for that exact part, we don't have it done so good, but can I show you a different part? Yeah, that doesn't work like that. Maybe as a tip, if you're a small team, if you're just starting, if the whole cost division of your team is just 2 people, maybe focus first on largest contributors, so you get the rough numbers correct. Don't focus on 0.05 grams for a piece of aluminium. Start with a good basis and then continue on, maybe next year's. Some general tips, as I said, make plans in advance. You should be already working on for quite a while on your cost explanation file on the day the rules basically came out. A good tip for you for the supporting material, big part of the largest part of the supporting material are technical drawings. Technical drawings shouldn't just be made for the cost report. Technical drawings are made for all the parts that you design. You have to make technical drawings anyway when you put them into production. This is how it's done in the industry. Don't just send STP files to your sponsor to have them made, because that's not how you learn, and it will just make double the work. And in the end, you will have to create like 50 technical drawings just for the cost report, if instead you could just do it throughout the year. Again, I know it's hard. Try to get the whole team involved. The team members that work on a system on the car know that system the best, know their parts the best. And also, please don't force the economics people to learn about manufacturing processes. Work together, so the total sum of work will be the least required. Practice looking up parts in the documents. That should be easy if you made them. With large teams, it can be difficult because the sections are then grouped together. So our advice is that get familiar with the documents. Don't open them up the first time at the judging, at the competition. Get familiar. If you want to find something, make it, design the document so it can be found fast. And just a general tip, not for cost, also for business, for design, get feedback from the judges. It helps a lot. Even if you think you've done perfectly, listen to the feedback. You can still find an improvement. We also listen to the judges. We asked some of the judges if they want to give any tips for you. Try to make the documents understandable to someone who opens it up on their computer before he even sees the car or before he even talks to you. All the documents should provide enough information to a judge so he knows what he's looking at, and to assess if the cost report has been done correctly. Don't avoid extra work if it means that you can show what you can do. Try to be complete. Think of everything that attributes to the costs. Way to think of it, if a team asks, yeah, should this be included in the C-boom? Should that be included in the C-boom? If you think of it, should it be added? You can add it. And also good presentation, dress up nicely, present the team, present the car, and yeah. Oh, okay. Is this the next slide? It is. Yep. There will be some changes from the FSG rulebook at FS Alpe Adria. They mentioned, FSG mentioned that in their handbook they will add a limit to the cost explanation file and the supporting material. Nothing will change here for Alpe Adria. We will have no limits for the documents. For the non-CC boom systems, for the cost supporting material, our current plan is that we will only require drawings for made parts. So the parts that are not bought, that are not standard, they should have technical drawings for the whole car, because you should already have them, because you've made the car. And for the CC boom items, as usual, drawings, exploded view, pictures of the vehicle if the part is not visible, and anything that helps to understand the bill of materials. The other thing at Alpe Adria, there will be no cost event finals, and as usual, the real case will be published on the first day of the competition, and then, of course, you will have a limited time. All the teams will have a limited time to come up with a solution, and of course, the real case will be appropriate, so it can be done in a short amount of time with not a lot of resources, maybe even without internet. Mostly your knowledge. In general, look out for the handbook. It will come out before the quizzes. All the changes, any other changes from the FSG rulebook, handbook, will be in our handbook.
Yeah, for FSA versus FSG, the differences. Overall, the structure of the cost report is similar, but not the same. So the CC bomb discussion will be similar to FSG. Also, the cost understanding part, at least the naming is the same, but our cost understanding, I will come to that later, how we will do the cost understanding, and we don't have any real case. So we don't care about this real case, so we scrap the third part of FSG. Yeah, as you saw, no real case. The scoring is format and accuracy of the documents, 4 points. We included in the handbook one specific thing, that the structure of, or the namings of the documents what you upload are in a specific order, and what has to be included and what doesn't have to be included. If it's not included, maybe there will be points deducted if you don't follow the rules in the handbook. Then knowledge of documents and vehicle. This will be assessed during the cost report itself. If it takes longer to find something, either it's in the BOM or in the CC BOM, in the supporting material whatsoever, we already have a feeling how well you know your documents. That's what Clemens said, train and know your documents, what you are uploading. The BOM discussion, including CC BOM, the normal BOM, will be 40 points and the cost understanding 50 points. So in total, if I haven't miscalculated, it will be 100 points. Same thing for FSA as for Alpe Adria, no page limit for the cost explanation files and also for the supporting material. So if you upload 20 pages, if you upload 40 pages, we don't care, as long as you know what you're uploading and you have an overview where is what. Because if you upload 1,000 pages and you take 5 minutes to find one specific explanation file, it will be a nightmare. So it's up to you. If you feel that 10 pages is enough, 10 pages is also enough. There is no upper or lower boundary. Regarding the finals, we will have an unlimited number of finalists. I don't know if FSG already took it over. Can't remember now, because FSG had, I think, 5 finalists. And we then change that to unlimited number of finalists. This will be the same as in the last years in FSA. So it can be from 0 up to everyone in the end. The best non-finalist will get the points they have before the finals. So when we discuss the scoring and then we come to the conclusion that the best, I don't know, 6 teams will get to the finals, for example now for the EVs, the 7th team will get exactly the points what they have during our discussion. The finalist scoring will be then, because it can be that the sixth position will become the best team or vice versa. So the lowest score of the finalists will be bigger than the best non-finalist. And the highest score will be, of course, 100. So if, for example, the best non-finalist has 90 points, the finalists will be somewhere between 90.1 up to 100. Can be everything. There will be no car in the finals, as in the last year as well, and maximum of 10 people. So from your team, if you're coming alone or with 10 people, both will be fine. Something in between. So compared to FSG, I think FSG said that the best non-finalist will be, only get 80 points. We will scrap that one as well. Then cost understanding. The cost understanding in FSA. The overall cost event will look like we come to your booth, then we will make a short introduction of ourselves. Then we will ask you about the bomb, CC bomb, for a specific time. Let's call it like that. And then we have a catalog with questions. I'm not saying how many questions, but there are a few of them. And we will ask 2 questions each team. Can be the same or can be different, doesn't matter. And then you will have 5 minutes of preparation time with your whole team. So it depends when your whole team is standing at the cost event as well, then you have the whole team helping you. If you are coming with 5 people, then you only have 5 people as well. You can come up with everything. So you can use already prepared presentation slides, posters, whatsoever, or you can come up with everything what you can imagine. And then you have 20 minutes presentation time, maximum. If it's less, and we are fine with what we heard in the first 10 minutes, it's fine. But after 20 minutes, there will be a hard cut, and we will leave your booth. Those questions are not necessarily connected to FSG or to from a student. So can be everything. Can be from draw me a layout of a full production line or whatever. So it's focusing now also a little bit more on CO2 emissions, CO2 reductions. You can call your previous cost report members of your team and ask them what they were asked. The questions in the finals will be different. So there will be nothing like, okay, this team got already a question A from within the cost understanding, and then this specific question A will be asked in the finals as well. This will not happen. So, Q&A from the Slido. Is the carbon footprint of each component required to be evaluated in the CC BOM as well, or just in the cost and emissions explanation file? Is the template on the FSG website going to be updated accordingly? What I heard from the FSG Academy, from Hannah, that I'm not sure, I think FS China is still using the old FSG tool. That's why they haven't updated it yet. Haven't checked by myself, but maybe it will be updated or is already updated. So in the end, there will be a new template at the FSG tool to include also the CO2 equivalents in there. And in the end, the carbon footprint of each component has to be evaluated and calculated. Because in the end, it's in the same structure as in a CBOM. You calculate it once for a drilling machine, the costs, then for a normal worker, the overhead costs, and for the material, the costs. And it will be the same as in the carbon or in the CO2 equivalence calculation. If you're using the aluminum, there will be a formula, or you come up with the CO2 equivalent per kilogram, and then you just calculate how much mass you need for a specific part. So in the end, for every part can be or should be the answer. Okay, see question and answers. If we have something in the Slido.
First, if we have any in the audience, maybe questions. We have some in the Slido, yeah. Engine and drivetrain we talked about. Will the supporting material file be limited to 20 pages as well to lift some workload with the addition to the CC boom? No. Should transportation/testing of the assembled vehicle be part of the CC boom as transport is required to be included?
As the testing is not part of your whole assembly and manufacturing process, then no. Because otherwise, it doesn't make sense at all.
Yeah, you also don't include fuel for testing, and so the answer is no. How many pages are ideal for the supporting material and the file explaining costs and emissions? How many pages are ideal? It's totally up to you. Like we want to see the perfect amount of pages, but it depends on what you write in. The perfect amount could be 2 pages or 45. It's totally up to you. The information must be presentable. When you open the document, you should know what you're looking at. And should include all the needed information for a judge to see how you achieved the calculation, how you did the calculations. Again, we don't concentrate on actual numbers in the end. What we want to see is how you did the calculation, how you got to those numbers. Do we have any other questions?
Let's see if we updated it. Looks like no. Yep.
Yeah.
That's it.
So.
Okay, thank you very much, Clement and Sebastian. Round of applause for them.
Yeah.
Coming up next is a very interesting topic about vehicle dynamics. I just saw my colleagues, they prepared quite a lot of material. And in order to give them a chance to present it all, I would suggest we make a very short, yes. Okay, sorry for the confusion. So we will start with the next presentation as planned in now 10 minutes, but it's going to be very sharp, and we'll see you in 10 minutes.
So hello, ladies and gentlemen, dear former student colleagues and friends. Welcome to our presentation about overall vehicle concept, safety and reliability. Today we want to talk about data-driven approach for general development and especially race car development and engineering. My name is Markus Bleschberger. The handsome gentleman right next to me is Christian Ablasser. And yeah, he's very eager to already start with his first topic, which is overall vehicle concept and how to define the right goals for your season. So please, Christian.
Okay, perfect. Then let's start with the presentation. So at the beginning, what is a goal? So is it at Formula Student a goal to have the funniest sticker, or is it to be on the podium at the dynamics, the static discipline, or on the oval podium? So for the goals, you can define at the beginning of your season, at the beginning of your team, you can define long-term goals, which are over a longer distance period of your team, which is over several years, which can be a development roadmap from now where you want to be in 3 years, and the short-term goals would be like, for example, like season-based, where you want to be on the season. And finding the right goals is not always that easy. So it's like you can do analysis your strengths and weaknesses from the past seasons. You can benchmark against other teams, what you are doing and what other teams are doing, or you can also do some, at the beginning of the season, doing some internal team workshops to prioritize your team goals. And of course, for having good goals, you should make goals measurable with the SMART approach. The SMART approach is defining goals which are specific, measurable, achievable, relevant, and time-bound. For example, you could set like a goal for the next season, like being in the top 10 of the endurance at FS Alpe Adria or FS Austria, and for that to be measurable, you can have a look for the lap times which were run on the competition, and you can define, okay, I have to be under a certain amount of seconds for achieving that goal. And then if it's achievable, it's based on your resources, which you have to quantify then afterwards if it's achievable for your vehicle, and it should be also relevant. So it should be relevant to the Formula Student competition, and time-bound is also if you're saying it, for example, next year at FSR 2025 or Alpe Adria 2025, it's also a time-bound goal, for example. And here is also for the long-term goals definition an example. For example, it would be the example you are at the moment a combustion car switching to an electric car. In the first year, switching from CV to EV, building your own battery, your own inverter, your own motors, and implementing a torque vectoring control system would be like in 1 year and target for a team, which is, I think, it's barely achievable. But if you're setting up a 3 years development plan, for example, to start with building your own battery, starting with an inverter which you're buying from a company and motors from a company, and after the years setting up to develop more things by your own, it's easier to achieve than to say like I want to do it within 1 year. And then we are coming to the overall vehicle concept. So what is the overall vehicle concept? The overall vehicle concept is the big picture of your development road of your car. So it's focusing on with that you're focusing on the main parameters of your car, which is the size of the car, the weight of the car, the aerodynamic values of the car, and the design philosophy of your car, and that's your basic ground. That's your ground base for the design process for coming to the submodules and to the single components of your car. Here the guiding principle is like with the design philosophy to set like your competitive goals, which is for example for performance, simplicity, or innovation. And you can implement like a design philosophy, complex but simple. With that means it's like you can have complex solutions on the parts and components where it really matters from performance point of view and reliability point of view, and on other parts, for example, and components, you can do the keep it simple strategy to use more straightforward solutions, which are components which are less influential for your performance and for your performance of the car. And so, and how to get the overall vehicle concept. So you can use some effort for the goal quantification. It's like at the beginning you can do a point analysis after your season for weighting the disciplines to the overall competition to see like where were you performing how by how much, and with that you can also use for getting an for identifying the key performance factors of your car. You can use lap time simulations. That must be also not like a very complex 4-wheel model or 2-wheel model. Also already for identifying the key parameters, a point mass. A simple point mass can already quantify most of the key factors for your car. And with that, you can do sensitivity analysis for understanding which parameters and which modules of your car are having the greatest impact on success. So, for example, here is now an example for a points analysis from a team from a previous year where you can see the maximum points of each event and how the team was performing. And with that, you can see clearly some trends of a team where a team can improve to get more points on the competition. And with that, you can already set some targets for your next year's goals. And then regarding optimizing the overall competition performance, in Formula Student, the winner is the team which has the most points in overall. So we already got in the previous presentations how you can gain points in statics. So for the dynamics, it's like in the dynamics disciplines, you can see there's one parameter which is in every discipline, and it's the time. So in skidpad, acceleration, autocross, endurance, there is every time the time is your target, and with the time you set, you're getting your points. So you have there one parameter where you can optimize your performance for the car. And with that, you can break down your goals into the modules. So you have the parameter lap time, and you can see like the influence of the aerodynamics, suspension, tires, drivetrain, powertrain, electronics, and vehicle dynamics controls, chassis, and of course also the driver is a big influence on lap time. And so you're coming now from the team goal to the overall vehicle concept. You can subtract it to the modules, and then afterwards to the components. And that would be, for example, the process overview. So at the beginning, you're defining your team goals. Then you translate your goals into performance requirements. Then you can develop the overall vehicle concept of your car. This could be also an iterative process, since some parameters are never fixed. And then you can set the module goals and requirements for every module. And afterwards, you can define the targets for your components. And then afterwards, you can define the targets for your components. And then, so what really matters for performance? Is it like spending 100 hours developing a new display interface with a smartphone interaction? For example, that during testing, when someone is changing the setup of the car, or you are in the scrutineering, that the driver can play some games with his smartphone on the display? Or is it spending 100 hours developing a new suspension kinematics? So it's up to you what to choose. But it's like for what really matters for performance is some parameters, like the first one would be the weight of the car, the height of the center of gravity, which have a big influence on the lap time of the car. The second one would be the tires and the grip. So here it is also meant the suspension grip and keeping the tire in the perfect operating window. The third one would be for the powertrain, the power of the car. Also it's also how much power you can draw on the endurance, and the autocross has also a big influence on your lap time. And for the electric cars, yes, it's limited to 80 kilowatts, the acceleration, but if you have a drivetrain which is more efficient, you can also gain their lap time. And the fourth one is the aerodynamics. So you see quite a lot of teams running aerodynamic devices and wings. That is, of course, also has also a big influence on the cornering performance of your car. And then the fifth one is the driver. So driver is building a car without a driver who can drive with the car. is like the driver is like the connection between the car and the path where the car should go. So driver is also a very important factor here. And the sixth one, which maybe some teams are not thinking that much about, is the reliability, because to finish first you have to finish. And also in the endurance, like here now in the endurance, you can see it's like the total amount of teams in electric and in combustion engine, which were running on the endurance the last five events at FS Austria. And you can see like the transparent ones. You can see like the highlighted bars are the teams which have succeeded successfully the endurance in FS Austria. And on the right side, you can see there the failure rate of the teams which are not succeeding the endurance in FS Austria. And it's for both categories. The last 5 seasons, it was over 50%. And for example, also in the electric category in 2022, for example, it was almost reaching 90% failure rate of teams which were participating in the endurance. So with that, from the reliability, it's maybe good to mention it. And I'm handing over the word to Markus, who can also introduce how to improve on reliability and risks.
Sure. Sure. I'm going to talk about risk assessment and prioritization because, like Christian just mentioned, there is a clear maybe loss of focus on reliability in Formula Student in general, as we have seen in the past years. And yeah, the idea behind this presentation was also to give some tools or like to give some ideas how to improve on reliability engineering and the overall risk assessment process. So I'm going to give you or like introduce here a tool which is commonly used like worldwide, but among Formula Student teams, it's rarely really used to its full potential. So yeah, I'm very convinced if you use this tool as I presented here, you're gonna for sure see some improvement. It may vary based on your resources or circumstances, but it for sure will improve your overall risk assessment and further on reliability. So the main point I'm going to talk about here is the decision matrix, basically. It begins with the identification of the parameter. So we need to know which parameters are important to achieve our goals. So if my goal is, for example, I don't know, I want to win every competition and every discipline and want to be the fastest, of course, performance is going to be a very, very important parameter for this goal. If I want to finish all endurances and want to, I don't know, be the first one to pass scrutineering, reliability is going to be a very important one. So those parameters are very important to identify. I'm going to show you in the next slide. After that, we evaluate the parameters based on our goals. So we say, okay, performance is more important than reliability, or maybe the other way around, or even resources is a very important factor for some teams. So we're going to dive a little bit into that as well. And then after that, we have basically our decision matrix. And then we put in, like the input is our projects or our decisions. And then we can evaluate which projects should be more focused on, or which projects need more, resources, money, time, whatever. And the last part is the actual prioritization, which is the final step in this whole process of this tool. So a little case study or an example. Let's take an imaginary team. It attended 3 competitions last year. It did not finish any endurance, which is sad, so they want to change something about that. On the right side, you can see their car parameters and their results in the competitions. And they set, as Christian introduced earlier, 3 smart approach goals, so yeah, specific, measurable, and so on. First one is to finish top 10 in skidbed in FS4A 2025. The second one is the best acceleration time at any competition should be below 4 seconds, and they want to finish every endurance. Well, those goals sound nice, but now we want to know how to actually achieve them and how to quantify them, because that's what we ultimately want to do. So, parameters. I've identified 4 parameters for this team, but if you do this analysis on yourself, you may come up with different things. For example, if you have unlimited money, which most teams don't have, but let's take it for an example, resources might not be your main concern and might not be a parameter. Or if you have unlimited amount of manufacturing power and machines and so on, maybe feasibility isn't an issue for you. So this is very, very individual for your team and for your framework in that you have to work in. But let's say those 4 parameters are, I think, quite common for teams to be very relevant for them. So after I identify the parameter, I need to weigh them or like evaluate them based on my goals. Here you see a matrix. Basically, I put in performance, reliability, feasibility, and resources. And then the rows are like the goals. And then I quantify on how much impact or how important is the parameter for the goal. For example, I just take one, top 10 in skidbed FS4A 25. Performance, like 5 is the very relevant and 1 is not so relevant. 4 I take here because it's a decent improvement from last year, but it's not like nearly impossible. It's quite ambitious, but a 4 is a good score here. Then reliability, of course, you need to have some reliability in order to get to drive the skidbed, but it's not like you need to finish endurance or something. And you got 4 runs in total, like 2 for each driver. So you have some room for errors if something happens. So 2 is the adequate score for reliability, in my opinion. Feasibility, it doesn't really depend on how complex your systems are, on how you design your parts, because skidbed is a very isolated topic from that. In my perspective, this might vary if you have some special conditions, but well, this is, as I said, very individual. And the last one, resources. We might invest some things, like for example, lower the weight of the car by buying better carbon fibers or something. So we definitely need resources, but it's not the main point. I do the same for the other objectives and goals as well. And then I get basically an average score for each parameter. And as you see, reliability is the most important for this team in this situation with these goals. And feasibility is the least important. So that's exactly what I wanted to do, to actually know where to weigh my parameters and what is important for my overall goal. Next is evaluation of the projects. Now I do the exactly same, but not inputting the goals, but the projects. Here I take as an example the chassis, for example, decision if I want to keep steel tube frames or I want to make monocoques, like a very simple, simple geometry with like just put carbon fiber on it and it will hold approach, or already a very slim and lightweight and optimized carbon fiber monocoque. And those are 3 options, and there I put in already, again, I put in those inputs, I score them, and after that you can see average score is like 3.75. And in this example, in the raw scores, the steel tube makes the most sense for this team. But we have still the weighted parameters, so we multiply the parameter score with the project score, and then we get basically like a total score, which will be, as you see, 40.6 for the steel tube frame. And in this example, it's very, very clear that steel tube frame is the right decision. So this isn't rocket science at all. This is very simple to do, but you need to do it. This is the big key point. If you follow this through, you will find a lot of interesting you will notice a lot of interesting decisions that have been made in the past and may be made in the future. So I really recommend to actually try it once or multiple times, and you will see some interesting results. So to give you a little bit of a bigger picture, this whole tool can be applied to every level of the team. So we can start by the management, for example, which would be the Formula Student team and the board or whatever they are called. And they need to decide whether to put money on, like they have some money left and they want to invest or something. They need to decide, okay, do I invest it into chassis or low voltage electronics or something? And this is a decision that must be made, and with this tool you can, this helps you to decide on a data-driven base what project is better. And the same for all the other levels. Very, very important here is it's a top-down model, so it doesn't make sense if you start from the bottom and go into the the more like management level at the end, because you want a holistic approach where you actually like give an idea and this idea spreads through all the modules evenly. Yeah, also very important, the higher the level of the hierarchy is, the more level or the more depth of analysis is required, because for example, if I want to choose between two connectors for low voltage or for the wiring harness, I can make that decision basically alone, or that this might be quite an easy decision relative to other decisions. So there's not a lot of analysis needed. On the other hand, if I have to make a management decision, it's very important to have a very, very good and profound analysis of what is going on, and if, for example, chassis or aerodynamics has more potential if I just throw money at them, or if they just have a better life and have fancy carbon fiber, but it doesn't do anything. So we need to really know and quantify what improvement could be made. And this is, again, with the tools and sensitivity maps that Christian showed you earlier. There you can actually quantify how much things bringing to the table or not. Yeah, and FMEA analysis, some of you might have heard of it. I will show it in the next few slides, but this is basically a special form of this decision matrix and risk assessment. So next topic is reliability specifically. As I said, this might be a big topic in Formula Student in general. I guess most of the teams have some kind of goal in regarding reliability, or they might say, okay, I want to build a reliable car, and we want to finish every endurance, but most of the teams don't really like quantify it, like every other goal should be quantified. So I want to give here an example how to actually do reliability engineering, or at least one approach that could be useful to you. So why is reliability important? I mean, first of all, obviously it is, because to finish first you have to finish. But here you can see the loss in case of system failure is far greater than the gain if everything works out. So this, some great engineer must have said it at some point, I don't know, but it is it's very true. If in the worst case scenario you can lose so much more than you can gain if everything works fine. So it's always about risk management. And this is also very important, because this slide tells you that do not touch any projects or components where you don't see enough potential just for fun, because the risk is still there, but there might not be any potential. Okay, this is quite a good, or this is a very important point about this whole topic. So the reliability process is basically analyze, monitor, and validate. Analyze is here. We start with the goals, and Christian earlier mentioned like the long-term goals, short-term goals, smart approach goals, and he focused on the performance goals. For example, I want to finish, I don't know, top 10 in skid bed, below 75 seconds in autocross or something. But there are also other categories of goals, which are, for example, reliability. This can be, I want to be very fast and the first one to pass scrutineering and to have a car that runs 1,000 kilometers in testing, I don't know what. There are a lot of different goals that can be made based on reliability. And as with all the other goals, you need to break them down into the modules. So the goal is for each module to know how can I contribute to this goal. I mean, ask yourself the question if every module leader of your team knows exactly why and how he or she can contribute to the goal that we want to finish endurance. Does everyone know that? Maybe yes, maybe no, but this is a very important question to actually think about. Yeah. And after that, we do the FMEA analysis, which will be here. So the key point of the FMEA analysis is to find the failure modes and how to prevent it, and to quantify the risk of it happening or how big the risk is for us as a team. In this case, we have a goal like to finish endurance. And in this example, I take suspension module. And the breakdown goal for the suspension is, okay, we should have no suspension failure, obviously. But we also shouldn't have any leaking fluids. And the ride height should be constant because you could get a DSQ in post-scrutineering. Yeah? So, and maybe there are more. I don't have thought about it very into the detail. That's up to you then. So now we have this matrix, which, as you can see, lists the potential failure mode for, in this case, for example, wishbone. There can be multiple failure modes for each component, but one in wishbone is, for example, mechanical failure. The potential effects of the failure is like a DNF if there's no other option, basically. Potential cause of failure is most probably, I mean, it could be manufacturing issues, but most probably it's like wrong calculation of forces, or like the structure, the mechanical is not strong enough to withhold those forces. And the important part of this whole analysis is to give it again those scores, like severity. 1 is minimal and 10 is very catastrophic. So 5 is, yeah, it's bad, but not too bad. And 10 is like really a broken wishbone and the wheel flies off or something. This is really catastrophic. So here we give it a 10. Occurrence is like how likely is it to happen. We give it a 3 because we had some, but it's not. Didn't happen that frequently. And detection means how likely is it that we detect it like beforehand, or how can we see if this is going to happen. And this is very difficult to detect it beforehand, so we give it an 8. And the final, or like the whole process, sums up into this risk priority number. And this is the whole magic about FMEA analysis. You can quantify all the failure modes into one number, and this number says how much this component is at risk. So 0 to 100 might be low risk. You can read the categories yourself, but there's very important to note that it depends on your scale. If you, I don't know, consider a flying wheel not to be catastrophic and give it a 5 because it's not too bad, you might never reach 500 in risk score. So really, it's a relative scale, and you need to compare your results. And that's very, very important to actually get good results in the end. And yeah, the outcome of this is the higher the score, the higher the risk, and the more focus and resources we should shift towards it. Practical tips for this whole analysis is, as I said, it's always subjective. It may vary between teams, sub-teams, even people in the same module or even the same person 2 months later. So this is really, really subjective, and it's not, so be cautious with the results and the absolute numbers. Also very important is to find the right scale, as I mentioned before. What is severity 8? It's already really bad, so a flying wheel should be probably above severity 8. And likelihood of detection 5, what does it mean? You need to find all those answers to these questions in order to get good results. And trends, not absolute numbers. As with all processes and simulations and so on, it's never about the absolute numbers, it's really about the trends. And if you see that one project stands out as to be very risky, you obviously need to focus on that. But if 3 are there up top and one has 2 points more than the other, it doesn't really matter. It's really about the big differences that you want to find out. And yeah, also as I mentioned shortly, results are only comparable if it's the same project phase, same scale of evaluation, and same level of detail as well. For example, if I make this analysis with the whole suspension part, like the whole suspension subsystem, and compare it with maybe, I don't know, some bolts or some things that are very, very into the detail, it doesn't make really sense. After that, monitoring is very important. You do this FMEA analysis, and you can see here at the very right, there's the action. So this action is like how to prevent this failure mode to occur. And as soon as you take that action, you need to monitor it. Because otherwise it's just a black box, you just try something and at the end you see if it works or not. So monitoring is very important. For example, in software, it's really important to implement debugging modes early on, because the later you do it, the worse it gets. And the worse it gets to actually know what happens to the system. So think about it early. For mechanical parts, it's mostly test benches or FEM simulations or so. So this is obviously very important, but also for this monitoring course, it's very, very useful. And yeah, for the VCU software, for example, you can also use some error messages with error codes that are very distinct, so that as soon as the error message appears, you really know what happens and in which subsystem, maybe even which error. So the better you can debug your system, the better your results will get. Then validation, also very important. You start by the component. So for example, I take the wishbone again, but I don't have anything against suspension guys, so don't worry. It applies for every other module as well. Take a wishbone, you test the basic functions, you make some stress tests or whatever you can and want to do with it. If this holds these tests, go into the subsystem, which may be the whole wheel package, for example, with the wishbones mounted already, or it might be another system. This really depends on your car and on your assembly. But yeah, there you have the first integration test and the validation of the first interfaces, which is also very crucial. If this is fine, you can go into the car, like in the standstill car, just build the whole car together and see if there's any issues or if you have any motion sweeps that you didn't do in your CAD system or some things that you didn't prepare beforehand, then you need to fix it. And as you can see, if something doesn't work, you really need to iterate and go one step back. Never go forwards and try to, or like never try to be, it's gonna be fine. As soon as we drive, it's gonna be fine. The problem will solve itself. Nah, that's never gonna happen. So always go one step back until you solve the issue, and then you can proceed to the next step. And then the last step, of course, is dynamic testing, which will be ideally simulation of the whole competition, and eventually also the endurance event, which is like the highest stress situation that you build your car for. And yeah, and with that, like with dynamic testing, I think Christian has some very interesting facts about that to say, so I hand over to you.
Okay, thank you. So now we're coming to the last part, to testing. So why is testing important? It's like the importance of testing is after you have built your car and assembled it, it's like you're going to prepare for the competitions. So testing there is very crucial for identifying some issues and problems, and maybe some reliability issues of your car to find it out during driving. So there are three different types of phases during testing. So the first one is the shakedown test, where you just assembled all the parts which you need for your car to keep it running, for seeing if the powertrain is working and everything is working from mechanical and electric point of view is working, that the car can drive itself. And then afterwards, then the full system integration period is starting. There you're increasing the power and the load on your components step by step for getting to a competition near performance level of your car and load level of your car that you can test your car into a competition ready testing. So it's very important because it's very important to be as soon as possible in the competition ready testing, because if you, like, for example, have some components still not manufactured and starting already testing with your car, you have and then after 1 month you're getting some upgrades on your car for example the aerodynamics. If you get them afterwards, some parts of the car, you have like some periods where your car is never finished how it should be at the competition. And for testing, to be very efficient is to set the targets the car should run in a dynamics ready state, that you can also say like the car can also positively go through the scrutineering of the car. And here in the competition ready testing, then there is the focus for preparing for the single disciplines and focus on to get as much as possible out of the car at the status after the manufacturing. So talking about testing efficiency. So the key objects for testing is to be efficient is that the car is in a scrutineering ready state as early as possible, because missing components of the car can influence the behavior of your car, and therefore it's always the target to have the parts as early as possible on the car. And it's also for being efficient. You should set yourself the target before the testing phase to have a detailed testing plan for with clear targets which you can set up for planning your testing days. Because if you're setting your targets for your test plan, the test day will start like that. At the beginning of the test day, you will discuss what to test, and with that you may go into the direction that you do some software tests, for example, for increasing the vehicle control software, but never testing an endurance, for example, before the event. So that is also another point on which you set yourself on the plan before the competitions. Plan several endurance tests where you really do it like endurance. So it's not having a total mileage over the day of 22 kilometers. That's not an endurance test. You really have to test like the first driver is driving 11 kilometers, then you do the driver swap, and the second one is doing 11 kilometers. That you really can see some reliability issues which you may have during the endurance. And also for that, since we're already talking about preparation for the competition, it's also important that before the competitions, all the drivers which are driving at the competition have enough driving time for the discipline to be prepared at the competition to know what to do. to be familiar with the car, with all the procedure for starting the car, and that they know what they have to do during that discipline. And yeah, for the preparation, at the test day, always come with a specific plan and also plan some backup options into it, because schedules are never fixed. So it could happen that that you have some problems with the car, that you also have a backup plan what to do if something is not working, for example. And do the preparation of the car beforehand. So if you can do it the night before, the day before, like stuff like, for example, VCU software flashing, doing some mechanical setups on the car, or maintaining some components, it's for the testing efficiency always better to do it beforehand if possible, because as already seen on the picture, I think everyone who was in Formula Student knows some test days where where half of the team is just standing around, the car is standing, someone is working on the car, and the other ones are playing with the smartphone and do not know what to do at the moment. And that can be maybe also improved with doing your preparations beforehand. And also for the testing efficiency, plan really some days where the car is not running on the test track for maintenance, and also for your data analysis. If you want to improve something and have the possibility to check log files, you can really set up some days where you're saying the car is not driving, where the guys really can efficiently having a look into the data. And then testing documentation. I know it's from testing not always the fun part, but it's for being in the complete development process. It's like testing and validation is the endpoint and gives the information for the starting point. So there is testing documentation is some stuff to do, which is then for the people afterwards and in the postseason quite good to know, and also at competition if you have to change some setups, quite good to know on which day what was set up on the car. And here is, for example, the testing documentation, a point where you track the weather data. It can be a simple screenshot from a weather app on your smartphone and implement it in a Word document, for example. Then also store with these documents the telemetry files of your car, or link it to it if you have the possibility to log files on the car. Then also a setup sheet, because every car in Formula Student is built to modify something during driving, and it can be changed because weather conditions are also not always the same. So you may have to change your setups for some weather conditions. There it's good to have a setup sheet documented, to have a look, for example, if you have a similar track temp on a previous test day at a competition, you can check the tire pressures, for example. And then also if you have video onboards, which are also sometimes quite useful for debugging if you had some mechanical failures. You maybe could see it on the video which part, for example, was the first one which was breaking, or also for the driver to see like that he can easily having a look what the other drivers at the test day were doing on the track to see if he can improve that or if he can copy the driving style. And then also a test day log where you're writing down on every time step what has done and who has done what, and also lap times for seeing like if you are doing, for example, in skid pad testing, if you can do some improvements with some setup changes. Then also another good documentation is the driver debrief. So the driver is actually driving with the car. He is feeling everything what the car is doing and how the car is behaving. So it's also quite important. It's a quite important information to hear to the driver what he was saying, or maybe also if he was struggling with some things on the car. And he can also tell you something about ergonomics. If there was something which was pressing on the shoulder that over the endurance test, for example, was hurting his shoulder and so on. And it's also for the driver debrief is also for driver training to compare different opinions and maybe find a middle way of a setup, for example, of the car. And then at the end of the test day, doing a team debrief for having everyone who was participating from module-wise on the test day, making with everyone a short debrief to see like they get from every module subsystem specific feedback. For example, from powertrain point of view, if the Accumulator guy, which has to be on the test day because you need an ISO at the test day, who can also give some feedback at the battery, then also component health, which you can check, and performance and reliability insights of some components, and you can also discuss, for example, some parts which have to swap for maintenance. And with that, which is also good to do, is doing a components runtime sheet. So to track the kilometers per component, so you can record the mileage for all your components, for suspension parts, tires, drivetrain, for example, the gearbox, and with that, you know, like the mileage, for example, how many kilometers you can drive with one set of tires, and then you can also put in an issue log where you document issues with components or systems that didn't perform on the test day as expected. So there, it doesn't mean that they have a failure, but just if, for example, they are not working as expected, that you document it, because then you can highlight areas during testing where you can improve, and you can set also a priority on them. And if you do this documentation, you can plan maintenance intervals. So there you can really schedule dates for replacements for some components before they are having a failure, based on the runtime sheet. So there you can ensure, for example, the reliability for critical components, because if you know, like, that one of your suspension component can just withstand the mileage of 75 kilometers, you can already plan to replace it before you run the mileage, and maybe risking at the test day and suspension failure. And afterwards, in the post-season, you can also analyze the lifespan and the reliability of components, and then you can see already for your next development of the car the weak points of your the weak points of your car, and critical components which had some reliability issues during testing, and you can already adjust them for the next iteration of the car. And then, yeah, it's also then for the optimization for the future performance, and you can use this data to redefine the reliability goals for the next year. And I also put in a picture of a component which I once did. So sometimes it can happen that something is breaking, but it's also important to go for testing, because during testing stuff like that can happen, but you also can see it. You can also analyze it, why it happened, and it's better to have it on the test day, and maybe can have a solution until already at the competition, than standing at the competition in the endurance and see your car has a suspension failure. And with that, I think that's it for our presentation. I say thank you for everyone who was watching and who was here in the room, and yeah.
Thank you very much. We are going to switch to some questions that we have. So, one of the questions is, how do you judge the effect on lap time if possible changes of your car that you cannot predict with a lap time simulation? Given that testing with the old car is also not possible.
Yeah, if I understand that correctly, for example, would be if you have a new concept, like, for example, if you're starting with from a combustion engine to an electric car, if you don't have an old car for testing and also don't have something on validation, there I think you also can have the data, for example, for electric car, for the components which you need, like the torque map of an electric car. And with that, you can already do some studies. Even if you know you didn't have the validation for that, you can already have a look. I don't put it on absolute numbers, but you can still follow the trends and see, like, how it's influencing the behavior of the car.
And maybe something to add is maybe this issue or this problem, this change some other teams already have gone through. So maybe ask or like look for teams who may have faced the same issues or the same change in the concept, and ask them what they learned about it, because yeah, from the student teams are very open-minded to exchange information, and maybe that's your best shot you got apart from the answer that Christian gave you.
Okay, then we have just one more question which I will answer. So the question is, when there are cars on track which are very different in speed, because one of the car might be already basically broken down and it's only limping around with 30 kilometers an hour, what can be done to prevent this? Because the faster car can only overtake in like designated overtaking zones. Yeah, I mean, so the answer is you have to look at it from our point of view, from the event point of view, and also from the point of view of the slower team. Would you like, as the slower team, to be basically dropped out of the endurance and not get a chance to score like any points in the endurance? Or would you like to have the chance to basically, yeah, limp home with your half-broken car and still get some points? We have to draw the line somewhere. We try to manage the overtaking process as good as we can. And the most important thing we do at FS Austria is limit the overall number of teams, so that basically at the end every team which can take part at the dynamics will have enough opportunity to do so. You just have to take your slot at the endurance. And that brings me to a very important topic which we always have at FS Austria. Please show up to the dynamics when they are open. It's always the same thing. We have 4 or 5 hours of endurance or dynamic runtime, for example, for the skidpad event. And all the teams turn up in the last half an hour, and then they are very disappointed when they cannot get all 4 runs in. I mean, yeah, why do you think we have 4 full hours of runtime? We need more than half an hour to get everybody through for 4 runs, so please use the available time. And the same is true for the endurance. You have to be ready when it's your time to start. When you're not ready, the next team will have to start. Then, of course, they have to be ready before they thought they would have to be. And it's a cascading effect. Yeah, and it's just be ready to drive and drive when you should. Yeah, one last segue before we get into the documentation. Adding on to dynamics stuff, please make sure when you're testing, when you're driving with your car, that you also follow some very basic safety precautions. They are to be found in the rules. But basically, you should have your impact attenuator on your car. Of course, your chassis with your main hoops has to be complete. You have to use your full driver's safety equipment. And also, of course, fire extinguishers are an important thing. And there should be somebody who can handle the fire extinguishers. It doesn't really help if you put one out on the track 20 meters away and nobody is there. And electric safety. Yes, thank you, Eugen. You can already come on stage. Yes, electrical safety for electrical cars is, of course, also a big issue that you have to follow for testing. And when you consider some kind of testing track, you should, of course, also make sure that you have some kind of runoff zones, and on the outside of your curves where a car could drift off, maybe it's not a good idea to park your transporter car or just sit around in the sun. Okay, thank you very much for the extremely professional presentation from our colleagues here with regards to dynamics, and we will have a direct segue into the next topic. Ich bin zu dumm dafür. Okay, so we had, before we start with documentation, we had some more questions with regards to mechanical and electrical. I'm filtering now for electrical. Yes, so we have the question, is it okay for the green tassel circuit to be implemented one outside of the TESAC and one in the car?
Yes, this would be okay, but consider that you are this stuff is scrutineering twice. So you have to show that it's working at the accumulator, at the hand card, and you have to show afterwards that it's working in the car. So this point when you have the whole logic inside the accumulator, then you just unblock the connector and you show everything's working. If you have all the electronics in the car, it might be longer time in the electric scrutineering.
So the easier way out is just to have it in your TSAC. Okay, next question. Directly for Eugen. Most TSMP banana plugs have a copper thread. Putting on a full metal lock nut will break them. I've heard of many teams that loosen the nut beforehand, which is obviously not the intent. What would you suggest?
I don't know, to be honest, I don't know. I saw the lock nuts that were working, but yeah, I don't know. Maybe I will give you an answer later. We'll have here the discussion.
So I guess this banana plug has to be locked?
The nut on the end, die Schrauben hinten.
But you could also use a tap washer for it.
Yeah, tap washer would be fine, yeah.
So maybe this is an alternative, not using a full metal lock nut, but a tap washer for this. Okay, next question. What is the intent behind rule change EV3.3 with regards to the 100 milliohm limit?
I think we had this already.
Yes, we already had it. Sorry for that. Are you able to solder a nut to a BCP to fix it in place and then screw your maintenance plug into it? Or will this be counted as a soldered connection?
To be honest, I would count this as a soldered connection.
No.
Maybe make a rule question about this, but
I think this refers to soldering in the context of the high current path.
Yeah.
But this is the attachment of a PCB and not electrical connection, as I understood.
I don't know. Make a rule question. That's quite simple. That's not. Make a question with some pictures, some renderings. How this is intended.
I think the normal design is that you have a hole in your PCB and you just bolt it to some kind of metal plate or something.
Yeah. So if you only solder the plug to fix it when you start, that you can handle the screw, that's better. And at the end, it's holding by the screw, that will be okay. But I don't think that is meant here.
Okay. The explanation regarding the inverted app signal was off. Yes, okay, that is a good point. But what I drew on the page was sorry, so I have to read the question. The question is regarding the acceleration pedal position sensor, where you have to have two signals which are non-intersecting. And of course that is true with regards to the range that you have. So I drew on the page the range from 0% to 100% of throttle position. Within that range that you're using, these two signals must not intersect, so that at every point the logic can clearly say, okay, I have a valid signal, and can differentiate it from a short circuit where both signals would be shorted to the same output.
But if you mechanically limit your pedal way, the sensor has much more weight than you use, then it would be okay. But it have to be two different sensors, and I think still with two different power supplies. It is given by some sensors on the market. Difficult to say why, because it's in the rules. We had this discussion 3 years ago, 5 years ago, when it was implemented in the rules. basically because it's automotive standard. There was some error constructed that can happen. I'm also not really happy with this, so in my opinion it would be okay, but it's stated in the rules, and why not?
I think the problem is if you have basically a mechanical issue and the offset between the two sensors starts to get close to zero, then you have the problem that then again...
But in this case, the ECU should turn off anyway.
Yeah.
Yeah. So yeah, we had a discussion a few years ago about this, and I said, yeah, okay, I don't care anymore because it's simple to implement it.
But again, if you have a very specific question with regard to your throttle position sensor, you can write this rules question anytime and attach the data sheets, and then we can give you a much more founded answer to that. Last question with regard to EVs. We have PCB bus bars made from FR4. Is this allowed? Can you please explain another time?
Make a rule question about this, and there will be a rule change in the rules version 1.1, and there will be a rules FAQ exactly about this topic, where everything will be explained. Quite good. But you can make a rule question now, or you can make it at FS3 or at FS Austria as you want. It's not so easy, it's not done in 5 minutes, but there will be a solution. Nice.
Yes, and as I understood, FSG will post also some example pictures in the FAQ ticket.
Exactly.
And then it should be much clearer what we mean. Basically, there is a problem if you, quote unquote, do not use good engineering practices with regards to FR4. You could end up in a situation where you have not a proper electrical connection, and that has to be avoided. And the rules ticket will further explain that.
Yep.
Okay, we will check if we have some more mechanical questions. Yes, two. With regards to power ground effect, there is a noise limit, 106 decibels. Yes. I have to explain why did I put this in there. The power of a fan or device to move air does not have a good correlation with the maximum sound level it can achieve. So it is fully possible to have like a 500 watt device which outputs like 150 decibels of sound. So I was afraid that some teams who did not agree with our decision to remove power ground effect will turn up with 500 watts of like a sound machine, which is just blasting everybody away. So I wanted to put some kind of limit into the rules. But yes, generally speaking, it would make sense to enforce it in the same way as the current combustion vehicle limit, which is measured half a meter away from the source of the sound in some like 45-degree angle. But to be honest, if your cooling fan is louder than 106 decibels, I think you are doing it wrong, to be brutally honest. Yeah, so it was just more like a liability to make sure that teams don't make very crazy ideas. And the last question, before we go to the documents, we have how are we planning to inspect the chassis in case of a newly manufactured one? Well, that is quite easy. If you are using basically exactly the same chassis, or you're using the same chassis design for a second year, we might require you to make a proof in your SCS that you actually have manufactured a new chassis. For example, you could post a picture of the newly manufactured chassis or new chassis in manufacturing process next to the old car, which has the starting number, which is clearly identifying it as last year's car. And what will restrict the tubular frame teams to just paint the old ones again? Well, the same thing. if you want to tell us that you have manufactured a new frame, you have to show us that there are at least 2 frames. And if you can only show one, then you have a problem. So yeah, it might not be a good idea to just melt down your old car and crush it. So you should keep it around for reference in this case. Or of course you could just make significant changes to your chassis. Then it is quite obvious that you have manufactured a new chassis, and it is, yeah, you won't be asked to make a further proof. Okay, so this is it for the questions, and now we're going into the last big topic that we have for all of you, which is the documents. Okay, so in Formula Student there are quite a lot of documents. I give here a short overview. We have the SCS, the Structural Equivalency Spreadsheet. We have the SE3D, which is the 3D model, which is accommodating the SCS. We have the EAD, which is for impact attenuated data. These 3 documents are for all vehicles, regardless of the powertrain. And then we have some documents which are special case for the different powertrain designs. So for electric cars, we have the electrical system form, the ESF. We have now the accumulator SCS, which is now a separate document. It is not found in the overall SCS anymore. For hybrid cars, we have the hybrid system safety form. And for the hydrogen cars, H2, we have the hydrogen safety form. Generally speaking, why are we bothering you with so many documents? The problem is there are many rules, and it's just impossible to check everything at the scrutineering at the event. Yeah. So many of the rules we are checking through the document review process, and of course you spend a lot of time preparing the documents. But we as organizers, as event officials, we are also spending a lot of time reviewing these documents. And I know it can be frustrating sometimes because it takes a lot of time to get the review after the deadline. But you have to keep in mind that for all of Europe, all this work is done by volunteers. So most of us have full-time employment, and we're doing this in our free time. And you can imagine it's not always the most thrilling experience to go through the 50th SCS document in your free time. So yeah, sometimes it takes another deadline to approach. In our case, the deadline is our events. So by that time, we have to look at it. And this is why sometimes it takes a bit longer. Sorry about that. Of course, we want to make sure also that we try to catch bad design choices from the teams, so that we do not end up with bad awakenings at the event where we have to say, okay, you made a bad design choice, you cannot use it, you cannot drive. We try to prevent this and make sure we find it out earlier in the process. Yeah, and we don't ask you for the documents just to get in your nerves. It's really about just making sure that every car is safe and that the process is possible even. The SES, Structural Equivalency Spreadsheet, there has been a question about it, why it is not the same for everything, for every competition. I have to disagree, it is the same for all of Europe. We use the same document template for every competition which has the FS rules. Of course, I cannot speak for competitions which used other rules, but within mainland Europe, I would say, which at this case has to exclude Italy, but every competition within mainland Europe which uses the FS rules uses the same SCS template, and we are all organized in one group to review these documents. So we are in one big review group. The same is true also for the ESF document and the ESF review. And it is also true for hybrid documents and hydrogen documents. So we are connected within Europe. We try to keep the process very much on the same level for all of Europe. And I'm sorry if you didn't feel this way. Please let us know of any details where you don't think this is the case. I don't want to say anything more about the SCS because my colleagues from FSG basically already said anything which is relevant for it. I've put you into the slides here the link to the FSG Academy slides. Of course, these slides will be available online in the next few days. Yeah. With regards to impact attenuator datasheet, many teams use the standard impact attenuator datasheet, but some teams are still using alternative designs. We're starting a Slido poll right now, checking out if maybe this can be even more streamlined. Because I personally believe that the weight savings which are still possible with regards to alternative designs are very minimal. But maybe teams are just interested in the process and they want to watch their own designs being crushed in the crash test, and they think that is interesting, I don't know. So this is why we have a Slido poll. Anyway, we are working to streamlining this EAD document process, especially because we think that the standard design could be very, the document process for the standard design could be streamlined. Yeah. Now for DSF.
Yep. I will take over. Okay. So about the ESF. So as Hockey already said, it's not about going you on the nerves to punish you or something like this. It's to help teams. Basically, as Hockey said, it's the same for the SCS and the ESF. There are some stuff that's really hard to repair on the event side in 1 week. The goal of the ESF is that you get a feedback a few weeks before the event, that you can order new parts, you can fix something. Yeah, lower the risk that the teams have to fix the things at the event. But this is also a past ESF does not mean that you will pass scrutineering. There are always stuff that is not controlled in the ESF that will be shown at the scrutineering, and it also can happen that something was clearly in the ESF stated, was passed in the ESF, as it is at the scrutiny at the event said, okay, as it is done, there is a problem, and yeah, and this is the issue, and also you have passed exactly this solution in the ESF, it can be still a problem at the scrutineering. At the other hand, an open ESF point doesn't mean that you will fail at scrutineering. So I know that we have much less power to review all the ESF than we should have. So if some of you want to leave the team and want to join FSI or FS Alberta or FSG or something else, we always need ESF reviewer. So a few ESF numbers. Last year we had 10 events in Europe that used the FSG ESF tool. So when you uploaded ESF for one of these events, it was passed for all others too. So we had 196 ESF controlled from 169 teams. There are 9 forms per team, and we need between 50 and 30 minutes per ESF form to review. So let's say 20 minutes per form. This concludes to 500 hours of review time, and we are only about 20 reviewers. So about 25 hours per reviewer, but these are not students anymore. They are working guys, they have family and so on. So quite much time. So ESF's do's and don'ts. In the ESF form, you have some fixed values. They are easy to review. They are normally you can go pass. That's fine. The problem or the difficult stuff are schematics and drawings and so on. At the schematics, you are allowed to upload PDFs, and you can do everything in the PDFs. Please don't put essays in these PDFs. A good schematic don't need a description because you see everything on the first side. Give good names to your inputs, to your internal variables. So name your wires. What is this wire to it? Is it low active, high active? So every minute, so the reviewer should have one look at your schematic and should know exactly what you are doing and if it's okay, if it's rules compliant or not. Use the names that are given in the rules. So shutdown circuit, just write SC in, SC out, and yeah, everything is clear. When you have different boards and so more than one schematic through the whole car, you have different boards and you go with one signal to another board via the wiring loom. Use the name or similar, use the same name or similar name, so that I immediately understand, okay, this signal leaves the board now, enters the other board here, and it's the same signal, and I can have a better look, or a better overlook. Do not overload pages. Only one function per page. That's a basic rule. Now, most people learn this at university, or when you start designing your own PCBs. Paper isn't very expensive. Use much of them. And always current and signals flow from the top to the bottom and from left to right. That's also, it keeps it simple to understand what your schematic is doing. Yeah. And the ASES, I think Kokio will take over again.
Yes.
Yeah.
We have now outsourced the accumulator. Sorry, now you can hear me. As already mentioned, we have now removed the accumulator part from the SCS. It is now a distinctive document. It's called the Accumulator SCS or ASES. Basically, it is the same as before. It covers the same topics as it has when it was still part of the big SCS. It's just a new structure. And we hope we will have specialists which focus on the ASES and the accumulator SES, and they don't have to deal with all the other parts of the SCS anymore, because until now you had to be a specialist for monocoque chassis, you had to be a specialist for tubular chassis and accumulators, and only if you had all knowledge in all three fields you have been able to review an SCS. So we try to streamline this. And with regards to the structure of the document, for example, you can see on the right, there is a reworked structure on how to implement data sheets. So it's basically, you have to first fill out what is shown in this data sheet. Does it show the mechanical properties and the fire rating properties which are relevant here? And then you insert a proper picture and not just give us basically a whole load of PDF pictures from data sheets, and we have to find the values that are interesting for us on our own. There is also a new structure on how to implement fasteners in your accumulator, which should also give you more help on how to implement it. And of course, it should help both sides. It should help you to understand what we want to see, And once it is properly in the document in a good structure, then it is faster for us to review it, which helps you as well in the end. Then we have 2 more documents which are specific to your powertrain. So we have the hybrid safety form. It's currently in a Word format, so a text document. We do not plan to make any big changes for 2025, so you can already use the 2024 template for reference and already start on filling it out. We want, by reviewing this document, we want to get a good overview of your system design choices. And if you have some very questionable design choices, we want to be able to give you feedback on it. This is why there is a document deadline for it in March, I think. And in the end, we hope that once we went through the review process, that you don't have any problems in the technical inspection with regards to your hybrid system. And the very same thing is true with regards to your hydrogen safety form. So this is, of course, going to be a new, completely new document corresponding to the new hydrogen class. But it is planned to be quite similar to the hybrid stuff. And again, the goal that we have with this document is to stop very bad design choices early in the process where it is still able to change them. And in the end, that we have a smooth technical inspection. So this is it now with regards to documents. I think we have just 2 short questions. I think we can turn off the presentation. So we have open questions. Documents. So one open question is, the SCS is a very crucial and important document for the competitions. Why would it not be standardized? So yeah, I already tried to answer it. From my point of view, it is standardized. It is the same document template for all of continental Europe, which use the FS rules. We have a European review group, and it would be really appreciated if you have some clear feedback on that, to just write us what the problem is, because from this question I really cannot understand what you mean. And then the last question for the big round. Some things in the SCS are not mandated in the rules, nor are they clearly visible in the SCS itself. Basically, they are hidden in the background of the SCS formulas. This kind of stuff can only be found in academy slides. Why is that? I agree, it should not be like that. Generally speaking, we only try to enforce stuff in the SCS which has rules in it, and I am a big proponent of that. So in the past there have been some quite heated discussions about it, because some people from competitions which shall not be named tried to implement something in the SCS template which was not to be found in the FS rules, and that should not happen. I fully agree. So again, here, if you find examples of that, please let us know specifically what you mean, because generally speaking, there is like the rule, some laminated structure has to be equivalent to like a tube of this size, and of course there will be a lot of formulas in the background which prove that the stiffness is the same and the strength is the same, but the rule is very clear, and it should all be, yeah, clear, and it should not be inconsistent. So please, if you have specific examples, please let us know. Okay, with that, we are now in the exit polling phase. So we have 2 small exit polls. I will also open it up, I think, here for the on-site. How do I go? Oh. Yes, here. So these are the 4 questions for the on-site participants, also shown here. So we make this kind of academy event in order to improve the communication and feedback process with you, the teams. So we want to give you information that otherwise we wouldn't be able to get to you, because of course the rules document, it has to be very short and precise and consistent. We cannot just write hundreds of pages of notes and pictures into the rules. But of course, also there is already a lot of existing tools. So for example, we have the FS Germany rules question tool. There is also a rules feedback tool. But also, of course, if there is something that you want to ask as one event specifically as FS Austria, you can write emails to us as well. I can see here that two things are quite clear. You're not really happy in the way it is, so you would like to see more interaction, direct interaction with us, like at this event. So this is, of course, a big thank you to you that this kind of event is appreciated, because of course it is also a lot of effort that goes into it. But I can also see that you would like to have improvement of already existing tools. So for example, I mentioned the FSG rules question tool. We are aware that currently, especially the answering time is not really where it should be. FS Germany has set for themselves an answering time of 2 weeks for rules question. I'm aware that currently it is not meeting that requirement. And you can bet I'm doing all I can to improve that, but it's not always easy. Okay, so thank you very much. For the on-site participants, we have food and drinks outside. We can switch now, I think, to the overall grading of our event. How did you like the FS4A event? Don't worry, we will still have one more session for you, but I guess some of you will tune out, because the secondary stream will be tips for new teams, and also asterisk tips for teams which might not have the most resources. So my colleagues from RP Adria will continue in the secondary stream. Note, for the secondary stream, there is a new link on the left. We had to change it because we messed up, but you can find the new link, it should work. And here in this room, in this primary stream, we will continue with some specific topics with regards to hydrogen, but I understand that many of your teams are not really focused on that, so you might tune out and grab a beer. And of course, for the on-site participants, we have also something to eat. So thank you very much. Thank you for participating, and hope you have a great evening. That was a very slow clap.
It was the right topic, so.
Okay, so we make a very short break, and then I will be with you here with regards to hydrogen topics. Okay, thank you everybody who is still here. This is our final session here in this primary room with regards to hydrogen. I also already talked a lot about hydrogen in my very first presentation with regards to how hydrogen works as a fuel, which kind of rules we have specific for hydrogen combustion and the hydrogen fuel cell in order to make it somewhat competitive with the other cars. I will not reiterate on that. You will be able to find all the slides online in the next days. So I will just give you some more general information here at this point. There is now already a hydrogen rules document. It says clearly that you can only use hydrogen in the gas state. So you cannot use cryogenic or liquid hydrogen. Any kind of high pressure component has to be clearly certified according to current standards. And you must not modify it, of course, because then the certification would not be relevant anymore. Because of safety concerns, we have currently limited the hydrogen system to 350 bars of pressure. And we consider all parts of the hydrogen system to be quote-unquote critical components. This is relevant with regards to mounting of these components. It is referenced to the new rule T9.3.1, and it's basically the same rule as for mounting the accumulator in an electric vehicle. We understand that a hydrogen tank is quite a lot of size and volume, so in most cases it will not fit in the back of the car. But this is not a problem because you are definitely allowed to use a side pod for your hydrogen components, given that it is strong enough, so you need a structural side pod. It has to be compliant with the basically side impact structure requirements. And in order to make the whole thing work, there are additional sensors in the shutdown circuit. So for example, if your tank has too high of a pressure, it has to trigger the shutdown circuit just like the other sensors. As I already said, there are hydrogen rules published. We published them at the beginning of October. We wanted to provide a basis for discussion. And if you have feedback for it, please send it to us. Until now, honestly, there's not a lot of feedback which came in from the teams. You can always write to hydrogen@fsworld.org. You can see it here. You can also find this email address on the FS Austria website where the hydrogen rules have been published. And we're definitely open for feedback for another full week, starting now, so until the end of November. And it's definitely open for discussion. We can talk about anything. It has just, you have to give us good reasons to make a rule change. Hydrogen at FS Austria. We are having 3 slots reserved for hydrogen cars. If you want to have one of these slots, you have to submit a hydrogen application before the quiz. This will be more or less the same process as with the wildcard slots. But you still have to take the quiz itself, like every other team, because the quiz determines your order on the scrutineering schedule. So even if you are chosen as one of the teams which gets the hydrogen slot, you still have to take the quiz. But to be honest, currently it looks like if you're building a hydrogen car and you are able to finish it for FS Austria, you are almost guaranteed to have a slot reserved for you. Now to some safety standards with regards to hydrogen at FS Austria. We are in very close contact with the Red Bull Ring, so the venue for our event. They clearly say that in closed buildings, they do not want to have any hydrogen, and they would like to have it only within precisely defined areas. So the dynamic area, of course, will be allowed to have hydrogen, and we will also have some kind of hydrogen storage area, but outside of that, it should be avoided. Teams may only work on the hydrogen car if the car has been certified hydrogen-free by the officials. We're talking about that later on. We are going to make a pressure test of the hydrogen system with helium. This is the closest gas with regards to atom size to hydrogen. It is the second smallest gas atom, and this is used to leak test your system before we put in hydrogen. In order to make sure that you can work on your cars at the competition, but also to make sure that you can work on your cars at your university, we have decided that we want to have a removable hydrogen tank. So the tank should be removed from the vehicles directly after driving, and the rest of the system in your car will be flushed with an inert gas. And the hydrogen tank will be stored in a safe designated area, and the rest of your vehicle basically is then, it's actually much safer than any other car at this point because it doesn't have any fuel in it anymore, and only the fuel cell cars which will have batteries. Yes, and as I already said, the tanks will be stored in a specified area. Some details of the scrutineering procedure with regards to hydrogen combustion cars. The mechanical scrutineering will be done basically as usual, but without a hydrogen tank at this point. Then we would like to make a tilt test using a dummy of the hydrogen tank. So you should make some kind of dummy which has the same mass and the same center of gravity as your hydrogen tank, which is used for the tilt test. And only then we are making the hydrogen scrutineering. And then, of course, once the hydrogen scrutineering is done, we make the noise test and the brake test. For the hydrogen fuel cell electric cars, we would like to make the accumulator scrutineering and electrical scrutineering as usual, without the hydrogen tank. Also, of course, the mechanical scrutineering. And then again, specifically, we are making the hydrogen scrutineering, and only then the rain test where the fuel cell should be running, and the brake test, of course, where the fuel cell should also be active. The details of the hydrogen scrutineering are currently still under development, but it is necessary that you have hydrogen safety officers, for which we are trying to provide a training session. Maybe we can again put up the Slido interface for the hydrogen safety officer training, if you haven't seen that before. So we are going to provide a training session for HSOs, hydrogen safety officers, in end of February 2025. There will also be, as I already mentioned, a hydrogen system form, the H2SF, which is also currently under development. But as I said already, it will be quite similar in structure to the hybrid system form. With regards to specific components like the tanks, pressure regulators, release valves, and so on, we would like to see, as I already mentioned, data sheets. These components, most critical components, should be off the shelf and already certified. I'm not sure. Yeah. If you have any questions, of course, ask us anytime, hydrogen@fsworld.org. And here are some details about how to leak test. So from our perspective, it would make sense to make a two-stage leak testing procedure. So the first stage is to flush the system with helium until no oxygen can be measured again at the farthest point of the hydrogen system. Then push up the helium pressure up to the nominal pressure of the system. So typically that is like 30 or 40 bars in your fuel cell or combustion vehicles hydrogen system, and then check all of the components with a helium detector for any leaks. And only then, when this test is positive, only then we are going to introduce hydrogen into the system. So we are going to attach the tank and fill the system with hydrogen, and then again make a leak-proof test for hydrogen. As I said, hydrogen is the smallest atom there is, and helium is already 2 times bigger. So it is possible that your system is completely leak-free with helium, but hydrogen could still pass through very small leaks. And only when everything is tight with regards to hydrogen, you will get sealing stickers for hydrogen. Flush the system. Yeah, so this is again, as I said, our offer for hydrogen safety officer training. It's going to take place at the 22nd of February 2025. It will be in Karlsruhe at Karlsruhe Institute of Technology. And we would like you to check out the specific Google form that we prepared for you in order to see how interested you are into that. I have, I think, 2 more slides. 3 more slides. So specific of how to bring your car to the hydrogen hot state. So the idea is that you arrive with your car, which is fully leak tested at this point, at the safe hydrogen tank transfer area. So maybe we can work on that acronym. Yeah, but the idea is that you come with your fully scrutineered car to basically a tank filling station. The officials check if your car, if everything is sealed and you have all your stickers on it. Then we connect the tank. It is very closely monitored, so there is a maximum number of people allowed there. Then you have 2 valves, one before and one after the pressure regulator. So you have a specific sequence for opening them. And there is, of course, a final leak check at the tank if this connection is also leak-proof with regards to hydrogen. Then the system will be slowly filled with hydrogen until at the farthest most point of your hydrogen system we can detect hydrogen. And only then it is considered to be completely leak-free, and you are basically ready to go. You will then get a sign posted on your main hoop which says hydrogen system hot, and you can push your vehicle to the dynamics area or the testing area and start your engine, but you have to be escorted by an official, so you cannot push your hydrogen hot car into the pit areas, for example. The other way around, how to get to the safe status again. Basically, you're going the other direction with the steps which we mentioned before. And at the end, you attach a sign, hydrogen system safe. So the long form is discharged and inert to the main hoop. and then you are free to do with the vehicle whatever you plan to do. So typically you go into your pit area. If you're working on your car, as I said already, you can only do it without the hydrogen tank. And if you're working on the hydrogen system itself, you have to let us know, you have to get permission. You are going to break the seals which are on each and every connector. And once you are done with your work, you have to come back to us in order to retake the leakage test. And to be very clear, you can only do it in that order. You cannot break your seals and afterwards ask for permission if you are allowed to do something. That will get you in trouble. We have some open points. As I already said, the hydrogen system form is currently under development. It's still it's going to be quite similar to the hydrogen safety form, to the hybrid safety form. Sorry. The rules are, as I said already, they are also still open for feedback. So if you have any feedback, please give it to us. And also a challenge which is remaining for us is how to refuel the hydrogen at the event and also for you during your testing phase. So we are in various discussions with sponsors on how to do that. Of course, you also understand that you as teams have quite a lot of challenges. It's not easy to find parts, especially tanks, valves, and fuel cells, which are suitable for your application as Formula Student teams, because most of the stuff you can already find is like automotive grade, which is typically far too large for your applications. We also understand that handling hydrogen by students is a big risk. We want to mitigate that, as I already said, by providing a dedicated testing and, no, sorry, not testing, making our training event in Karlsruhe. And it is also an issue on how to transport a hydrogen car to the event or to your testing site, because this could be regulated as hazardous good transport. And as far as we understood, it would be best if you could transport your hydrogen tanks within your hydrogen car, because then it is not considered hazardous goods anymore, but we're still figuring that out, the details of that. Yeah, so open points for the future. We want to, we're trying to standardize parts. So we hope that the hydrogen tank and also the on-tank valve can be standardized, maybe even a fuel cell, we have to see. Of course, we're going to further improve the hydrogen rules as needed. And we're working on a standardized interface and process on how to refuel the hydrogen in your case. Yeah, so now we're finished with the presentations. I will, for a final time, go to the Slido. Yeah. Do we still have people watching?
Yeah,
Okay. So I hope that somebody is still hearing what I say. So the first question we have with regards to hydrogen is a removable tank is a massive security flaw. At some point the coupling gets damaged. A fixed tank is much safer. Is it still possible to change this rule? To be honest, no. Because we are of the opinion that it is not feasible to have a hydrogen tank with hydrogen inside in the pit or even in your workshop at your university. There has to be a process to completely remove any hydrogen from the car, which will definitely include the hydrogen tank, because most hydrogen tanks, they cannot be fully emptied. So there's always some kind of hydrogen inside. So the only possibility you have is to remove the tank from the car, make the process to declare the car inert, and then you can do whatever you want to do with it. We have in the rules a connection device. I think it is already not called a quick connect anymore, because this does not have to be quick, quote unquote. Yeah? It is completely fine if the process of removing the tank or disconnecting and reconnecting it takes like 10, 20 minutes. That from our point of view is completely fine. So if it is not feasible to have a quote unquote quick connector, it is also fine to use like some kind of flange with bolts, and it will also be completely fine to use new washers for every time this has to be connected and disconnected. Because if it's just a very normal round washer or seal type, that would be feasible. And from our point of view, disconnecting and removing the tank from the car is the only way to get approval from the event site and also from your universities to even do that. So I'm afraid, no, this is not really up for discussion anymore. At least until we have found a way to show universities and also event sites that hydrogen by itself is not more dangerous than petrol, it is just different. But currently, everybody says hydrogen, it's like from the devil, and it's like the most explosive stuff ever. And they just have so many precautions for it that it's just not feasible without removing the tank from the car. Does the vehicle status video still apply for hydrogen vehicles? Generally, yes. I would suggest if you have a hydrogen electric vehicle, you can make the vehicle status video using just your battery. Yeah. So that I would say is completely fine for us. We just want to see that you have a driving car. But if it is driving under the power of a battery or your fuel cell, we won't be able to tell from the video. With regards to combustion vehicles, I would say yes, you should be able to drive your car already with hydrogen for the vehicle status video. Yeah, because just like every other team, you have to show that you have a driving car. But if you have problems with your timeline, just let us know where you are. I think this is much more suitable for a 4i discussion. One team competes with one car each for EV and hydrogen combustion. Does this team present the same business plan in both presentations? No, so in your case, when you have one car in the normal EV class and a second car in the hydrogen combustion class, then you are competing with two teams and they have to be separate, definitely also with regards to the statics. So you have to have two different team structures and two different static teams. So also you cannot share team members for your engineering design presentation. It is the very same process as it has been in the past, where teams had, like Karlsruhe, for example, they had one electric vehicle and one combustion vehicle, and for the purpose of the competition, they were treated like two different teams. And now we have the last question. Will the quiz be the same as the class we compete, or are we having our own hydrogen quiz? No, you will take the same quiz. As already said, the quiz is relevant in order to determine which position your scrutineering will take place. And also we have to find if there are more than 3 hydrogen teams who are competing. Of course, the 3 with the best quiz score will get the hydrogen slots. You will compete in the class which is relevant for you. So when you have a combustion hydrogen car, you will compete in combustion class, and fuel cell in electric vehicle class. So yeah, I hope that answers it.
There's one follow-up, I guess, on the attached detached question. So maybe you can refresh it for also.
Yes. So the question is, a hydrogen tank can be flushed. Well, not really. A hydrogen tank only has one opening. And if you try to make a hydrogen tank completely inert, so remove any kind of hydrogen, you would have to put in inert gas, open it up to atmosphere again, put in again inert gas, and again and again. If you have a system with an input and an output, it is much easier. You just open up the output valve, put in inert gas at the input, and wait until at the output no hydrogen comes out anymore. Also, as I said, there are a lot of tanks, hydrogen tanks, which cannot be fully depleted. So there are tanks which need at least 10 bars, for example, of pressure inside at all times. It's really not feasible to flush that every time. And also, what are you going to do with all the hydrogen that you did not need? Are you just every time putting out all that hydrogen into the atmosphere? This is a whole different safety critical problem by itself. So I'm really sorry. At this point, the only thing to make it feasible for us in Formula Student is that you have an on-tank valve, you close that, you disconnect the tank from the car, put it into a safe hydrogen tank storage area, you flush your car, make it inert, and then you can go off and work on your car. If you have another process on how to do it, please get in touch. I cannot think of another process that will actually work for our needs with the universities and with the Red Bull Ring. Okay, I think we have done it. We are at the end. Thank you very much, and cheers. See you again, hopefully at the competition. And if you have any questions, as I already said, please write us an email. You can also contact us directly. You can find all contacts at our website. I am the head of the overall head of Scrutineering, but we also have a specialist just for hydrogen stuff. It's Stefan Schmidt. You can find him on the homepage. He's the head of hydrogen. So definitely you can also write him. He didn't have time to join us today. So yeah, again, thank you very much. We are closing just in time, as we said. No, we are closing 15 minutes earlier, but that doesn't matter because... Thank you very much. See you. Bye.